Yeah, good afternoon, everyone. Welcome to the day 5 of our E&S City Faculty Development Program on Artificial Intelligence Application for Engineers. So today there is a slight change in the schedule. In the second session, instead of Dr. Jitendra Kumar Rao, Dr. Santosh Kumar Sahu is going to take the session. So I request all of you, those who are interested in hands-on session, you are requested to install Orange. Let me write in the chat box. So you can install Orange tool. So sir will give you some demonstration on Orange tool. So you can write Orange machine learning tool or data mining tool. You can install that tool so that you can do hands-on with the speaker, Dr. Santosh Kumar Sahu. And in the first session, we are going to see the nearest neighbor-based classifier. Although one algorithm was covered in the day 2 by Dr. Midan related to KNN, but today you will see several variants of this nearest neighbor algorithm. So I'll again repeat that what do you mean by that nearest neighbor algorithm, and we'll see one illustration related to the nearest neighbor algorithm. Then we'll look into what is the drawbacks of that NN algorithm, and we'll see several variants of the nearest neighbor algorithm. So all these, if you look into like yesterday class also, we have seen different kind of learning, like supervised learning, unsupervised learning, reinforcement learning. So this classification and regression that comes under the supervised learning. Okay, but if you will see tomorrow's lecture related to the clustering, that is unsupervised learning. So these are the topics that we are going to discuss in this session. We'll start with a very simple nearest neighbor algorithm, even if it is not a k nearest neighbor algorithm, but it is simply called as nearest neighbor algorithm. Later point of time, people finds that there are some drawbacks of nearest neighbor algorithm. That's why they have proposed several variation of nearest neighbor algorithm. One of such variants is called as your k nearest neighbor algorithm, where your input is k. So your decision is depends upon k different points or k different patterns or k different friends. So it is performing better in comparison to nearest neighbor algorithm. However, KNN also suffers from some issues which is addressed and which is solved using modified k nearest neighbor algorithm. So you have seen that in various research articles, they focuses on KNN, but KNN itself having some issues. So you can, in that case, you can apply the algorithms which I am going to discuss in this session. One of such algorithm is called as modified nearest neighbor based algorithm. Similarly, nowadays, we have fuzzy theory, fuzzy logic, right? We have also one session related to that. So you can apply such thing in the KNN also. We call that algorithm as fuzzy KNN algorithm, where you cannot say that a particular pattern belongs to class 1 or class 2. Rather than you can say it is 0.4 if you take the whole value as 1, 0.4 to the class 1, 0.6 to the class 2, which I can say the membership value of that particular pattern. So we'll see that example that is called as fuzzy KNN algorithm. Although you will see another variants which is based on the radius. So that is called as R near neighbor algorithm. So this algorithm finds the neighbor based upon the radius. If you increase the radius, then definitely the number of neighbors is increasing. If you take radius is a very small number or a very small value, then you will see the number of neighbors are less. So these four are different variants of the nearest neighbor algorithm. Although these are outperform one in comparison to another, but there are some efficient algorithms that you can apply in artificial intelligence, machine learning, which can provide you better result. Some of these algorithms are called as branch and bound algorithm. Second one is called as the cube algorithm. Third one is called as searching for the nearest neighbor by projection. Fourth one is called as ordered partition. So these are nothing but the efficient algorithm in comparison to several variants of the nearest neighbor algorithm. I'll tell each and every algorithm by the help of example with its theory, right? So that you can easily map how actually a decision of a test pattern takes place when we apply such algorithm. And at last, we'll discuss about the summary of this lecture, and I'll give you the reference. So let us start with the first one, that is called as nearest neighbor based classifier. So nearest neighbor classifier is a very popular classifier, and it is not new. It is quite old, and it classifies a sample based on the category of its neighbor. You have to see what is the category of its nearby objects, nearby patterns. Based upon the class level of the neighbor, a particular test pattern is classified into that class. Suppose your nearest neighbors are belongs to class 1, then you will classify the test pattern as class 1. Right? It purely depends upon what is the class level of each and every object or pattern. Like one of the example you can see, you are given with a basket of fruits, and I'll tell you to segregate these fruits. Okay, and before that I have mentioned the class level is, one class level is called as apple, another class level is orange, another class level is banana. So you have to take one fruit from the basket. You have to classify either that fruit to an apple or orange and banana. Similarly, you put the second fruit and decide whether it is apple or orange or banana. Right? So this decision, what you are taking, whether it is a orange or apple and banana, based upon the shape, based upon the color, based upon different properties. But when we go for different patterns, we consider the distance is one of the popular measure to see that this object is near to an existing object. That's why this classification is based upon the objects or the pattern which is close to that particular pattern. Similarly, this nearest neighbor uses some or all the patterns. Every time for a particular test pattern, you need not go through all the patterns. Like suppose you have 100 patterns. If a test pattern is 101, for this one pattern, you need not refer to all the 100 patterns. Right? So that is not a feasible solution, you can say, because for each and every pattern, if I check whatever the patterns that are available in my history, so it is very complex task. That's why in worst case we go for all the patterns. In some cases we are able to take a decision with a very few number of patterns. That's why it says that some or all patterns available in the training set to classify the test pattern. So you have two type of things. One is called a training set, another is called as testing set. Training sets, you know the class level. Testing set, you have to predict the class level based upon the model you have designed using the training set. And how we actually do here, one of the measure is that I told you, that is a distance, or you can say similarity between two different patterns. If similarity between two pattern, okay, if similarity between two different pattern is very high, then you can say whatever class level is there for X, the same class level is there for Y, if they are similar. If they are not similar, then you have to find a particular pattern which is close to or which is similar to other pattern, right? Similarly, here what we are doing, we are finding the similarity between the test pattern and every pattern in the training set. Suppose you have three pattern, one is A, B, C, and there is a new pattern that is D. So what you will do, you have to find the similarity between A and D. You have to find the similarity between B and D. You have to find similarity between C and D. Okay. And suppose the similarity is with A. A is more similar to D. So what I will do, I will find the class level of A. Let's say the class level of A is 1. So I'll assign the same class level to D. But the problem is that now if you take three objects, it is looks very simple. But when you go for machine learning, you will find the number of samples are quite high. So checking one test pattern with each and every possible pattern is a very difficult task or time consuming task. Okay, it is practically not feasible. Right? Now, let us see how these objects look like or how this pattern look like and how to represent it in the form of tuple. So let us consider that there are n different training patterns. These training patterns are nothing but x1, x2, x3 up to xn. Not necessarily these patterns are in 2D coordinate or 3D coordinate. It may be in any dimension. And here xi is the dimension of D. Xi is of dimension D. Suppose you want to represent in 2D coordinate, then you can say there is a x coordinate and there is a y coordinate. Or let me represent it x11, x12. Similarly, for this one, if you represent in two-dimensional one, it is 21, 22, and so on. And this is the first one, which may be any dimension. If two dimension, you have two values. If it is three dimension, you have three values, right? Like if you know that color image case, we consider three coordinates. One is for red, another is for green, another is for blue. Right? You have to have a value for R, value for G, value for B. And this theta 1, theta 2, theta n, they are nothing but the class level of ith pattern. Class level means you can say there are three class level, like I mentioned, apple is a class level, orange may be a class level, banana may be a class level. So that class level is given to you. So if you are going for 2D pattern, you have three values. One example is, suppose I will say 1.2, 1.3 and 1. What it indicates? It indicates that 1.2 is the x coordinate, 1.3 is the y coordinate, and 1 is the class level. Right? Now, a training set is given to you. In that training set, you have n samples. Right? So now, if I take a pattern P, which is called as a test pattern. Okay, P is a test pattern. So what I have to do? I have to compare P with x1 theta 1, P with x2 theta 2, P with xn theta. So actually we are comparing with x1, x2, xn. Theta 1, theta 2, theta n are the class level. Right? So if I take P comparison with x1, P comparison with x2, P comparison with xn. Right? So you have to choose this comparison means this is nothing but calculation of the distance. So one of the popular distance we know that is called as equilibrium distance. that is we are using for calculating the distance between 2 points. If 2 points is given to you, you have to know how to calculate the equilibrium distance. So I have to calculate the distance from the test pattern P to the training patterns, that is x1, x2, and n. So some values will come and you have to choose the minimum value. So d of p and xk, d of p xk, right? D of p xp is your test pattern. Xk is nothing but the class level of p, which we don't know. You can find, if you find the minimum of distance of p xi, right? You calculate the distance with x1, calculate the distance with x2, xn. Suppose you are getting 1.2, 0.8, 3.4. So if you find the minimum one you will get is 0.8. So you can say the test pattern P is closest to x2. Okay, the test pattern P is close to x2. Then you have to see what is the class level of x2. Suppose class level of x2 is, let's say, 2. Class level of x1 is 1. Class level of xn is 1. So as the class level of x2 is 2, the class level of this test pattern is also 2. That's why the pattern P is assigned to the class theta k associated with xk. So in our case, it is x2. So we assign to class level theta 2. In this way, the nearest neighbor algorithm assigns the class level of a test pattern. Right? Now, let us take a small example to discuss whatever we have till now discussed. Let us illustrate through a numerical example. So let us consider that our training set consists of 3-dimensional patterns. It may be a 2-dimensional pattern, it may be a 3-dimensional, it may be n-dimensional pattern. The meaning of saying here it is a 3-dimensional pattern is that the first coordinates says that it is x coordinate, second coordinate is your y coordinate, third one is your class level. Right? If you take this x1, 0.8 is your x coordinate, 0.8 is your y coordinate. This one is nothing but the class level of x1. Right? That's why you can see here, or in machine learning perspective, you can see the first two numbers in this triplet, they are nothing but two different features. Right? If you go for 4 values, let's say 0.8, 0.5, 0.4, and 1. So these three are 3 different features. Right? So if I say you take a piece of graph paper and represent 0.8 and 0.8 in that graph paper, what you will do? You will take 0.8 in x-axis. So this is your x-axis, and 0.8 in the y-axis. Here we represent x-axis by x1, y-axis by x2. So you can see you will find this particular sim in a particular position, which we represent by plus. Similarly, if you go for another pattern, that is x2, okay, in which x value is 1, y value is also 1, x value is 1 and y value is also 1, then the class level is your 1. Here in this case, your class level is 1. Right? So you can find the in graph, this is the value where x-axis is 1, y-axis is also 1. Like that, you can see there are 5 different patterns. There are 5 different patterns. Okay, there are 5 different patterns. They are having class level 1. What are the class levels? The class level is x1, x2, x3, x4, and x5. These 5 patterns are having class level 1. Similarly, if you go for x6, x7, x8, x9, x10, x11, having x12 also having class level 2. And rest, that is x13 to you can say x18, having the class level 3. Right? And if you represent it in the form of a graph, you will see these are the respective positions. So total we have 18. Total we have 18 patterns. Right? Now you are given with a test pattern. So this is your test pattern, which is given in a square, right? So now if I ask you, like if this is your class level 1, let's say this is your class level 3, this is your class level 2. Okay. Now if I ask you, this particular test pattern belongs to, let me write class 1, this is class 2, this is class 3. Now if I ask you whether this test pattern belongs to class 1 or class 3 or class 2, how to determine? So for that case, you have to calculate the distance for this particular pattern P to each and every pattern. Okay, so see here. Let's say our test pattern is 3 and 2. Means x-axis it is 3, y-axis is 2. So you can see x-axis it is 3, y-axis is 2. So this is your test pattern. Right? Now I don't know whether this pattern belongs to class 1 or class 2 and class 3. You have to do calculation in order to decide whether it is belongs to class 1 or class 2 or class 3. So for that, we have calculated the distance between each and every test pattern, each and every training pattern, that is called as X, and this test pattern P. So when you find the distance between X and P, so that is nothing but x1 minus p1 whole square plus x2 minus p2 whole square. Like if there are two coordinates are there, one is x1, another is y1, another is x2, and this is y2. If I ask you to calculate the Euclidean distance, then the answer is x2 minus x1 whole square plus y2 minus y1 whole square and its root of. Right or not? The same thing we are doing here. So if I ask you this test pattern P, let's say this pattern is x1. Find the Euclidean distance between these 2 points. X1 is your 0.8, 0.8, and P is nothing but 3 and 2. Can anybody calculate the distance between x1 and P? Distance between x1 and P. Can you write in the chat box how much you are getting? What is the value you are getting? If I find the distance between x1 and P, where x1 is 0.8 and 0.8 and P is 3, 2. Any answer? So what you will do here? How to calculate the Euclidean distance? You will say 0.8 minus 3 whole square plus 0.8 minus 2 whole square and root of. Right? So if you calculate this one, you will get the value is 2.51. So the distance between the test pattern P to the training pattern X1 is 2.51. Right? But this is not only the test pattern. Okay, there may be number of test patterns. Similarly, we have seen the different returning pattern also. Like here x2 is there, x3 is there, up to x18 is there. So you have to calculate the distance from x1 to each and every pattern, right? Like x1, you have calculated p to x1 or x1 to p. You have to calculate for x2. You have to calculate for x3. Like that, you have to calculate for x18. Okay. You will get in each and every case, you will get a distance, right? So if you see here, these are the distance you will get. Distance of x1 to p already you have calculated as 2.51. Distance of x2 to p is 2.24. Similarly, you will find distance of x18 to p is 1.64. Now you have calculated the distance of this particular point P to all the training patterns. These all are training patterns, right? X1, these X values are nothing but the training patterns. Okay. Now you tell me which one is the closest point of P? Which one is the closest point of P if these are 18 different patterns? The lowest value, right? Which one is the lowest value? You can see 2.51, 2.24, 2.16. Is there any value with 1? Yes, 1.13 is there. Is there any value below 1.13? Yes, 1.12. Okay. So X16 is the pattern which is close to P because the distance is 1.12. So we can say the neighbor of pattern P is X16. What is X16? Let us revisit here. This is your X16. So X16 is nothing but its X coordinate is 3.5, Y coordinate is 1.0, and it is belongs to class level 3. Right? Now we have X1. Sorry, our test pattern P. If you take test pattern P, it is 3.0, it is 2.0. So how to know what is the class level of P? As it is a nearest neighbor algorithm, as X16 is the closest point of the test pattern P. So we can say the class level of X16 is the class level of the pattern P. So the closest neighbor of P as it is X16 and the distance is 1.12. So we can conclude here that it is belongs to class level 3. Okay. So this is called as the nearest neighbor algorithm. What may be the drawbacks? The main drawbacks with this algorithm is that if there is an outlier, okay, outlier is a point which is very far away from other points. If such a cases are there, outliers are there, so your test pattern may take the class level of that particular outlier. Okay, or it is close to the outlier, then it is creating a problem. And you can see the distance you have calculated for each and every point, but finally you selected the point which is closest one, right? So which may not provide you the correct class level. Sometimes it is not giving you the correct class level. So that is the main drawbacks with the nearest neighbor algorithm. So what we will do, we'll see different variants of the nearest neighbor algorithm to solve the problems of the nearest neighbor algorithm. Okay, whatever problem we face nearest neighbor, maybe with respect to outlier, or maybe you have selected only one pattern and based upon that you are assigning the class level. In order to avoid that, we have taken K nearest neighbor algorithm or modified K nearest neighbor algorithm or fuzzy K algorithm or R nearest neighbor algorithm. Okay, these all are providing better solution than nearest neighbor algorithm. Okay, so one by one we'll discuss with an example. So let us start with KNN. KNN, as the name suggests, instead of looking for a single neighbor, you have to go for k different neighbor. We are not looking into the one nearest neighbor's class level. Rather than we are taking k different neighbor, and based upon their class level, what we are doing, we are assigning the class level of the test pattern. Right? Like whenever we face a particular problem in our life, so we are asking for our friends. So it is not limited to one friend, but we are taking the opinion from multiple people. And based upon this multiple people, you decide which one is correct or not correct. Right? So the value chosen for k is very, very crucial. Whether to choose the value as 2 or 3 or 4, that is very much important. In fact, choosing the correct value is really a challenging task. Another important thing that normally the value of k is taken as an odd number, because if k is an even number, let it be 4, and two patterns, let's say one pattern is x1, another pattern is x6, another two patterns are x8 and x10. Suppose x1's class level is 1, x6 class level is also 1, x8 class level is 2, x10 class level is 2. Now, if you go for a majority, then there is no majority here because 1 is repeated 2 times, 2 is repeated 2 times. Right? That is the reason if I take k is equal to 5, let there is another pattern is x12, and the class level of x12 is 1, then the majority you will find here it is 3 for the class level 1. So you can conclude something. Okay. So let us take an illustration of this K-NAND algorithm. So I have taken the same training sets. This training test set consists of 18 different patterns. So let us consider the K value as 5. This is a random guess. Okay, because the value chosen for K is very crucial. So we consider the K value as 5. So instead of finding a single neighbor, we have to find 5 different neighbors. Okay. Now, if I go back to this particular slide and I'll ask you, okay, find the 5 different neighbors of P. So you have to find 5 different patterns which are closest to 5. Obviously, the first one is this one, right? X16, the first one. So you can see 1.12 means the nearest value is 1.13, so it will come. There's 5 patterns you have to choose. The next one, check 1.32 is there. Is there any value below 1.32? No. So you can choose X14. You have 1.41 here, right? I can choose this 1.41 because there is no other value which is below 1.41. Yes, also here also you will get 1.4. So what we can say here that x6, x7, if you go in a proper order, let me write in the proper order. X16 is having the distance 1.2, x7 is having the distance 1.13, and x14 having distance 1.32, x6 and x17 in any order having 1.4. Okay, so these 5 are the 5 different neighbors of the test pattern P. Right? X16, X7, X14, X6, and X17. Now let us know. Okay. Yes, Poonam madam answered it is 1.44. No, it is coming 1.41, right? We are selecting the least distance. So 1.44 will not come. If you increase the number of neighbors, it will come, right? Otherwise, it will not come. Now we found there are 5 different neighbors, but you have to see what is the class level. Now go to X6. What is the class level here in X6? It is 2. So I'm writing here 2. For X17, what is the class level? X17 is the class level is 3. Okay. X14, what is the class level? X14 is here, the class level is 3. X7 and X16. X7, the class level is 2. Right, let me write here 2. And X16, if you see X16, the class level is 3. So you have taken 5 different patterns and their class levels are 3, 2, 3, 2, 3 in this particular order. So you can see the majority of the patterns are belongs to which class? Class 3. You can see this pattern belongs to class 3, this pattern belongs to class 3, this pattern also belongs to class 3. Yes. So as 3 are belongs to class 3, so as for the majority rule, you can say the test pattern P is also belongs to class 3 as per KNN algorithm. So let us go back to that slide. The majority class for 5 patterns is class 3. That's why the test pattern is having the class level 3. However, the problem with this method is that there is an error in classification. Okay, it is not in the normal case. It will happen when the training patterns are noisy. If your data pattern is noisy, in that case, even if you are using KNN algorithm by taking k different neighbor, you will get error in classification. So let us take some other example to understand how actually how the errors are there in classification, how to reduce that error in the classification. What is the actual problem with the KNN? Okay, so see here. Here, if you see the test pattern is B. This is your test pattern, this one, right? And in the left part of P, you have 5 different patterns. Right part of P, you have another 5 pattern. Okay, you can say this is belongs to one particular class. These 5 points. These 5 points are belongs to another class. Now P is a point which is in between the class level 1 and class level 2. So now we have to decide whether P belongs to the class 1 or P belongs to the class 2. Right? So the test point P is closest to which point? If you calculate the distance, if I give the x coordinate, y coordinate of these 10 points, you can calculate the Euclidean distance with P and you can say the point 5 is the closest one of test point P. But if you see, even if this point is close to the P, okay, the test pattern P is close to the training pattern 5, but it is an outlier. You can see in class level 1, all the points, especially this 1, 2, 3, 4, they are more or less close to each other, but 5 is not close to each other. 5 is not close to all other points. So what happened before this particular test pattern? This pattern is test pattern. Try to understand. Now we consider this pattern as the test pattern, but before this pattern, we consider this is your test pattern, and we calculated the distance, and we found that it should belongs to this particular class. Now we are looking for this particular pattern, and its closest one is 5. So now these are belongs to the same class, right? This is also a test pattern earlier, but now this is a test pattern. So in both cases, it is belongs to the class 1. Right? You have identified a outlier, but we have not identified this. Identified belongs to class 1. So the upcoming values also, which is close to that, also belongs to the class 1. That's why the point P will be classified as belonging to class 1. But when you go for KNN algorithm, right, KNN algorithm case, you are not looking into a single one, you are looking into, let's say, K value is 3. K value is 3 means for this particular pattern, you found these three are the neighbor 5, 6, and 8. These three are the neighbor. And majority of them are belongs to which class? Class 2. Because circle belongs to your class 2, cross belongs to your class 1. So we can say the test pattern P will be classified as belonging to class 2. However, in practical case, in real life situation case, if you see, the value of K can be determined by experimentations. You cannot select an optimal value of K for a particular problem. Now, see the problem with KNN, another example. This is the problem of NN with KNN, but now we'll see the problem with KNN to go for modified KNN. Is there any question till now? Okay. So if the test pattern P is 4.2 and 1.8, okay, previously you have taken the test pattern P as, here you can see the test pattern you have taken is 3, 2. But now we have changed the test pattern to 4.2 and 1.8. So what I'll do, I need to find the distance of P to x1, P to x2. Like that, I have to calculate P to xn. Right? So if you find, you will find the nearest neighbor of P is x17. So I've calculated here. You can see the nearest neighbor of P is x17 and the value is 0.82. But if I take five different neighbor means I'll choose five least value. So 0.82, that is nothing but x17. It is the closest neighbor. Next to 0.82, you will find 1.00 for x8. The least distance you have to calculate. 1.02, you will get x11. 1.06 you will get for x16. 1.08 you will get for x7. Right? These are the five different neighbor. Now you need to find what is the class level of this neighbor, right? So class level of this neighbor, if you see, x17 belongs to class level 3, x8 belongs to class level 2, x11 belongs to class level 2, x16 belongs to class level 3, and x7 belongs to class level 2, right? So if I apply the majority class rule, then you can see the test pattern P is classified to class level 2 because x8, x11, x7, these three are belongs to class 2. That's why it is belongs to class 2. But if you compare with the previous example, which we have considered, in that case, by using the majority class, the test pattern P, which is 3 and 2, that is belongs to class 3, not class 2. So purely it depends upon what test pattern you are taking and who are the neighbors. Based upon that, you can take a decision whether it is belongs to class 2 or it is belongs to class 3. Okay. So now we'll moving towards another algorithm that is called as modified K nearest neighbor algorithm. It is also called as distance weighted K nearest neighbor algorithm. Before going to this algorithm, we should know what is the demerits of KNN. In KNN case, like if you go this example, in KNN case, you have selected five different neighbors and all the neighbors are given its equal importance, right? We have not considered any weight factor here. Age, we have not considered any weight factor. So all the weights are assumed to be 1 or they are negligible, right? Means weight we are not considering. So, but you can see X7 is very close to the test pattern P, but X7 is not close to P. Is because we have selected the nearest neighbors are 5. So X7 is coming. But if you compare X7 with the X17, the distance is there between X7 to X7, but still it is coming as a 5 nearest neighbor. That's why not to give a weight to each and every pattern? To give weight to each and every pattern. So definitely you will see importance will be given to the point that are more close, and less importance will given to the point which is very far away from the test pattern. Okay, yeah. Uma madam is asking to repeat this thing. So here you can see, like we consider for 5 NN by taking k value as 5. So we have not considered any weight value for X7, X8, X11, X16, X7. Okay. But if you see this 5 pattern, if I ask you which pattern is closest to the test pattern P, you will say X17 because it is having the distance value 0.82. If you see X7, it is not that much close to P in comparison to X17 because its distance is 1.08. But KNN is not giving any importance whether or less importance to X7. It is not giving any kind of importance. Importance means I want to say weight factor. But those values, like you are taking opinion from two different persons, right? You are taking opinion from two of your friends, but you are either aligned to or you are believing more to one friend in comparison to another friend. Okay, both are giving you some suggestion, but you can say this particular friend is very close to me in comparison to this one. So I'll give more weight, let's say 0.6 to this person, 0.4 to this person. That means this friend is more important to me in comparison to this friend's suggestion. Is it clear? So that I want to say here, X17 is close to P, but we have not given any special weight or more importance to X17 in KNN. Right? X7 is very far away from P, so we have not given less importance to X7. We have given same weight, or there is no weight means what? We are treated everything equally in KNN algorithm. That is the main reason why to move for modified KNN algorithm. See, the main idea of modified KNN algorithm is to assign a weight value. If you say weight value, then you will ask on what basis you are going to calculate the weight. So each of the neighbor is associated with a weight W, okay, based on their distance, and this weight you can calculate by taking the ratio of dk minus dj divided by dk minus d1. You can see in the denominator part, as we have dk minus d1, the condition we have written here, dk is not equal to d1. Right? If dk is equal to d1, this term is not defined. But if dk is equal to d1, in that case, you can consider the weight value as 1. And all the weight values are in the range of 0 to 1. Right? Now, weights of the representative among the k nearest neighbors sum to the greatest value. The meaning of this statement I'll tell you while I'll tell you an example. So let us see. And a simple comparison if you made between KNN and KNN, you can say KNN focuses on simple majority rule. However, MKNN based upon weighted majority rule. So you may have majority, but if your weight is not high, then your class level is not going to be considered. So in order to avoid this mathematical part, let us take a small example. I hope with this example, all the things are clear. Now I have considered the same 18 patterns here. My test pattern is 3, 2, which I have taken earlier in the very first example. Now, if I calculate the distance from P to x1, x2 up to x18, right? I found that the closest distance is x16. So you can calculate. I have also calculated, I have given the detailed calculation here. You can go through this calculation and you will see the closest point is your x16. But if I have taken M5NN, what is the meaning of M5NN? The K value I have considered as 5. So I have to take 5 different neighbor. So they are x16, x7, x14, x6, x17. Okay. And the distance is 1.12, 1.13, 1.32, 1.41, and 1.41 respectively. Now, I have to give a weight value for each and every pattern. I'm writing the weight value is W. So weight value of this pattern can be calculated as dk minus dj divided by dk minus d1. So you may ask me what is dk? Dk is nothing but the maximum distance. Okay, maximum distance between P and all the 5 neighbors. What is the maximum distance? The maximum distance here is 1.41. So I put 1.41 here, 1.41 here. Right? What is DJ? DJ is nothing but your current point, means x16 value, the distance of x16 value, which is 1.12. So I put 1.12 here. And D1 is the least distance. DK is the maximum distance. D1 is the minimum distance. So the minimum distance here is 1.12, this one. So you will see here the weight value is equal to 1. Is it clear why the weight value is equal to 1? Okay. Now you can see if I go for W7 case, DK value is same, D1 value is also same, because minimum distance and maximum distance for these 5 points, if you compare with P, it is 1.12 and 1.41. It is fixed. So only value that is going to change is called as this DJ. So the DJ value here, it is 1.13. The DJ value is 1.13. Okay, second value 1.13. So you will get the weight value as 0.97. Similarly, when you take W14, these 3 values are fixed, right? Only you put this value, that is 1.32. So you will get the value as 0.31. Similarly, you take x6, right? So these 3 values are fixed, right? The value you will put here, DJ value is 1.41. So you will get the value as 0. Similarly, here you can see W17 case, right? 1.41. These values are fixed. Only this value is required, that is 1.41. So you will get the value as 0. Now you can see here, right? In comparison to now you got the previous one where you look into the distance. Here we look into the weight value. Not only the weight value will solve the problem, but what you have to find now? You have to find what is the class level of each and every pattern. Okay. Like if you see the what is the class level of x16, I'm writing here class, which represent class level. Okay, I'm writing class level. Class level of x16 is your 3. Class level of x7, 2. Class level of x14, 3. Class level of x6 is 2. Class level of x17 is 3. Now you tell me how many points or patterns are belongs to class 1 out of these 5 different neighbor. How many patterns are belongs to class 1? Can anybody answer? There is no point, right? Exactly. Remember I mentioned that there is no class 1. So what we can do here, we can say class 1 sum is 0. Similarly, calculate class 2 sum. Class 2 sum. Class 2 sum, if you calculate, it is 0.97 plus 0. So 0.97 only. Class 1 sum is equal to 0. Class 2 sum is equal to 0.97. What about class 3 sum? It is nothing but 1 plus 0.31 plus 0. So we will get 1.31. Yes, it is 1.31. You can see in the chat box. It is 1.31, right? So now you tell me which class is having more weight. Which class is having more weight? Class 3. Yes, class 3. So definitely you will assign the pattern P to class 3. Okay. See the difference. Now I think the difference between KNN and you can say MKNN, you could able to identify. In KNN, we deal with only these values, right? Only calculate the distance value. But while selecting the class level, we are not considering any weight. Rather than we consider how many class levels are there for class 1, class 2, class 3. For example, in this case also, if you apply KNN, the majority of them belongs to class 3. That's why it is belongs to class 3, right? But MKNN case, what you are doing, you are assigning weight to each and every training pattern. Like here you can see 1, 0.97, 0.3100. These are nothing but weight value, right? And you are summing the weight values based on the class level. The class level having the highest weight value, right? That is the nothing but the class level of the pattern P. Yes, you can see here the point P is belongs to the class 3 based on this sum, and this sum is the highest sum. That's why we have assigned to class level 3, right? Now let us take another example. See this example. Now I have changed my pattern. Earlier the pattern is considered as 3, 2, but I consider the pattern here is 4.2 and 1.8. Okay. Instead of taking pattern as 3, 2, I am taking another as a test pattern, that is 4.2 and 1.8. And if you calculate the distance from 4.2 and 1.8 to x1, x2 up to x18, you will get these values. And out of these values, you can see the top 5 values. Top 5 value means the patterns that are having less distance, right? You will find these values, which is represented in blue color. That is x 17 will come first, then x8, then x11, then x16, then x7. Okay, and their distance value is 0.82. Your distance value is 1.00. This is 1.02. And what is the distance value of x16? X16 is 1.06. X7 is 1.08. Right? But this is the distance value. But what about weight value? Weight value we can calculate by taking the minimum distance and maximum distance. So it is nothing but dk minus dj divided by dk minus d1, where dk is nothing but 1.08. This is also dk, that's why 1.08, and d1 is 0.83. Only this value you have to put based on this particular distance. Okay. So for x17 case, what you will do? You have to put 0.83. So you will get the value as 1. Okay. Then for x8 case, the value is 1. You can see the value is 1. So if you calculate it, you will get the value as 0.32. Right? Let me write here so that you can understand easily. W17, W8, W11, W16, and W7. The weight values are coming as 1.1 and 0.32, 0.24, 0.08, and 0. And their distance also, if you calculate, it is 0.83, 1.0, 1.02, 1.06, and 1.08. Now, tell me, what is the class level of 17? Class level of 17 is 3. I'm writing here class level. Right? Class level of 8 is 2. Class level of 11 is 2. Class level of 16 is 3. The class level of 7 is 2. Now you tell me, if you apply KNN, which class level you will assign to the test pattern P? 2, obviously, because of the majority rule. Simple majority rule says that it is 2, right? But if I go for MKNN, let us see what is the class level. So there is no point belongs to class 1. So class 1 sum is 0. Class 2 sum, if I calculate, it is nothing but 0.32, 0.24 plus 0. So we will get 0.56, right? If I'm correct. Right? If I calculate for class level 3, then you will see which one. This one will come and this one will come. So it is 1.08. So which class level is having highest sum? 3, right? Yes. Chat box also madam mentioned about 3. So you can see MKMN says that you have to assign to, it is to the class level 3. So what might is my advice is that if any domain you are working where the KNN is applied and MKNN is not applied in the literature, you simply apply MKNN and see whether it is impacting the performance or not. If it is impacting the performance, you can go for a research article. Right? Okay. Now, yes, as you have already identified, if you compare this example 4 with example 6, then you can see pattern P is classified as belonging to class 2 in example 4 using KNN with K is equal to 5. Right? But another case you are getting class is 3. One case you are getting class 2, another case you are getting class 3. Okay, is there any doubt till now? Okay. If there is no doubt, then let us proceed to the next algorithm that is called as fuzzy KNN. Okay, so till now you are deciding by applying NN or KNN or MKNN, you have decided whether it is belongs to class 1 or class 2 or class 3. That's all. But Fuzzy logic says that you cannot completely categorize a particular pattern into class 2 or class 3. Obviously, membership value of that pattern in the class level is higher than the membership value in another class level, but completely you cannot say that it is belongs to class 3. right? That's why the elements of the fuzzy set have a membership function. And this membership function is the real unit interval in between 0 to 1. And in order to calculate the membership of a particular pattern P, membership is represented as mu I P. That is nothing but if I write mu 1 of P, that indicates this is belongs to class level 1. Mu 2P means it is belongs to class level 2. So in order to calculate the membership value of P, you have to use this particular formula. So I'm not telling you details about this formula because it will confuse you. Rather than I'll tell you a simple example so that you can understand how actually this formula works, right? So let us see one example, then I'll come back to this particular slide. Let us take the same example with 18 different patterns, and our test pattern we have taken is 3 and 2, right? Now what you have to calculate? You have to calculate membership value of pattern P. Okay, membership value of pattern P in class level 1, membership value of pattern P in class level 2, membership value of the pattern P in class level 3. But you can see, if I consider these 5 nearest neighbor, that is x16, x7, x14, x6 and x17, right? Let me circle this thing. Is x16, x7, x14, x6 and x17. You can see there is no pattern belongs to class 1. Right? Already you know this example in the previous case. There is no pattern belongs to class 1. So what you can say, the membership value of pattern P in class 1, it is equal to 0. Because none of its neighbor is belongs to class 1. Is it clear why the membership value is 0? Okay. Now you look into class 2. You know how many patterns are belongs to class 2? There is 2 different pattern belongs to class 2, right? So if you see the membership value of, if I ask you what is the membership value of x6 and x7 in class 2, it is equal to 1. Okay, for x6, x7, as they are belongs to class level 2, their membership value is 1. But x16, x14 and x17, they are belongs to class level 2. Sorry, class level 3. So this is class level 2. Sorry, this is class level 2. And x16, x14, x17 belongs to class level 3. So if I ask you what is the membership value of x16, x14 and x17 in class 2, x6, x7 belongs to 2. But what is their membership value in class level 3? It is 0. It is 0 because they are not a part of class 3. That's why it says that for class 2, mu ij is equal to 1 for x6, x7, and it is 0 for these patterns, x16, x14, x17. On the other hand, if you go for class level 3, you will see it is 1 for x16, x14 and x17, but it is 0 for x6 and x7. Right? So now if I take m is equal to 2, you can see here in the equation, you have to give the value m. So m is actually a constant, and this value need to be provided by the user. And a typical value we consider here, that is m is equal to 2. Then what you can do, membership value of the pattern P in class level 1 is equal to 0, because none of the you can say none of the neighbor belongs to class 1. But if you calculate the membership value of the pattern P in class level 2, it is nothing but 1 by 1.41 square plus 1 by 1.13 square. where I'm getting this value 1.41, 1.13. 1.41 is nothing but distance between x16, x6 to p. That is 1.41. Distance between x7 and p is equal to 1.13. That's why we are writing 1 by 1.41 square plus 1 by 1.13 square. But other neighbors are also there. What are the other neighbors of this pattern? They are x14, x16, x17. What is their distance? Their distance is 1.32, 1.12, 1.4. So in the denominator part, we have considered all such values. You can see 1.41 is there, 1.13 is there, 1.12 is there, 1.32 is there, 1.41 is there. So that will give you the membership value of pattern P in class level 2. So the value you are getting 0.406. Similarly, if you calculate the membership value of pattern, let's say if you calculate the membership value of pattern P in class level 3, how many are belongs to class level 3? X16, X14, X17. What is their value here? These are the values, right? You can see 1 divided by 1.12 square, 1 divided by 1.32 square, 1 divided by 1.41 square, divided by all possible patterns. So you will get the value as 0.594. So see, the same pattern P is having membership value 0 in class 1, 0.406 in class level 2, 0.594 in class level 3. So as the maximum value you are getting in class level 3, you can say pattern P is belongs to class 3. But it has a value in class 2 as well as it has a value in class 1. Is it clear? Okay. Then we'll proceed to the next algorithm, which is the last in the variants of KNN algorithm. That is called as R near neighbor algorithm. What we are doing here, we can look at all the neighbors within some distance R of the point of interest. Our point of interest is the pattern P, right? So we have to take a radius R. Within that radius R, okay, you have to find the neighbors. Okay, so this is the algorithm we have to follow. First, you are given with a point P. You have to determine the subset of the data that lies in the ball of radius R centered at P. So this is the ball of radius R centered at P, which is mathematically represented as this one. And if this BP and class R is nothing but R is the radius, right? In this radius, if you are not able to find anything or BR of P is empty, then output the majority class of the entire data set. You are not able to find a single pattern in that radius. Okay, so what you can say? You can say, as I have not found any element, majority of the class, if you remember, if you go to the previous example, okay, this example, majority of them belong to, I think, class 2, right? You can see 1, 2, 3, 4, 5, 6, 7. And 3 case 1, 2, 3, 4, 5, 6 case. Majority of them belongs to class level 2. That's why if it is empty, then output the majority class is 2, right? But if it is not empty, means within this radius, if you found some neighbor, then what we have to do? The output the majority classes of the data point in it. Suppose these are belongs to, let's say, 1, this is 2, this is 2, this is 2, and this is 3. Majority of them belongs to 2. That's why the result is 2. So again, like K, choice of the radius R is very crucial in our nearest neighbor algorithm. Okay, so let us take an example to understand how our nearest neighbor works. Now, let the training set consist of the three-dimensional patterns, which we are already discussing. 18 different patterns are given to you. Suppose the point P is 3 and 2. And if I take the radius as 1.45, take the radius as 1.45 means the test pattern is P, calculate the distance to x1, calculate the distance to x2, calculate the distance to x3. Like that, you have to calculate the distance up to 18. Okay, calculate the distance up to x18. And the radius is 1.45 means if the distance is less than 1.45, that pattern you will consider. If it is above 1.45, then that pattern you are not going to consider. So if you take 1.45, so you can see this is above 1.45, this is above 1.45, above 1.45. So I'm deleting it. This value is also greater than 1.5, 1.45, 1.45, 1.45, this is 1.45. So only the blue color one, these values are less than 1.45. Right? Now, what is the majority classes? So these patterns are nothing but, let me write here, x6, x7, x8, x6, x7, x8, x9, x14, x16, x9, x14, x16, and the last one is x17. What is the class level of these patterns? X16 class level is 2, x7 class level is 2, x8 class level is 2, x9 class level is 2, x14 class level is 3, x16 class level is 3, x17 class level is 3. Now, if you see, majority of them belongs to class 2. Right? Majority of these patterns are belongs to class 2. That is the reason why P is assigned to class 2. Right? P is assigned to class 2 because out of 7 patterns, 4 patterns are belongs to class 2. Okay. But if you are not getting any one within a particular radius, like here you can see the lowest distance you can see it is 1.12, right? Suppose I'll choose R is equal to 1. So none of these patterns, okay, none of these training patterns and the test pattern distance is less than equal to 1 or less than 1. So I'll consider the class 2. A majority of these patterns out of these 18 patterns, 7 patterns belongs to class 2, right? You can count the number of 2's, okay? So that is the majority R belongs to class 2. So the test pattern P also belongs to class 2. Is it okay? So in this way, the R nearest neighbor works. If you have any question, you can ask. Any question, anyone till now? Okay. Now, irrespective of the nearest neighbor classification methods which we discussed 5 algorithms: nearest neighbor, K nearest neighbor, modified K nearest neighbor, fuzzy nearest neighbor, and R nearest neighbor. These 5 methods, the methods are very, very time consuming. Okay, if I consider training patterns is 1 million training patterns are there or 1 billion training patterns are there, you will see really it is very time consuming. So in order to avoid that, what you can do, you can apply some efficient algorithms. So what are the efficient algorithms we have? We have branch and bound algorithm. We have cube algorithm. You have searching for the nearest neighbor by projection and ordered patterns. Okay. So these topics we will discuss one by one through example. So if you have studied algorithm paper in computer science, if it belongs to CSE, if you study design analysis of algorithm, you come across this algorithm that is called as branch and bound algorithm. Right? Let us start. So let us take an example. With example, you can easily understand. So we have considered 18 different patterns like previous examples. So suppose first I will perform some kind of clustering here. Okay. First I'll apply some of the some clustering algorithms on these 18 points. So they are belongs to three different clusters. And let us call these clusters are C1, C2, and C3. So the points of class 1 is taken as one cluster. Those are belongs to class 2, they are belongs to another cluster. Those who are belongs to class 3, they are belongs to another cluster. Like here you can see the point x1, x2, x3, x4, x5, they are belongs to cluster 1 because their class level is 1. But if you go for the point x6, x7, x8, x9, x10, x11, x12, they are belongs to class level 2. Similarly, x13, x14, x15, x16, x17, and x18, they are belongs to class level 3. Right? Now you have divided into 3 clusters based upon the class level. What you have to do now, you have to further decompose them into the subcluster. Like cluster 1 can be subdivided into cluster 1A, 1B. Cluster 2 can be divided into 2A, 2B. 3 can be divided into 3A, 3B. Okay, based upon the need. Now, let us see there are some values are written here. So before going to this value, you can see here, these are the points as I told you. First 5 points are belongs to cluster 1. Next 7 points belongs to cluster 2. Next 3 belongs to cluster. Next 6 points or rest points are belongs to cluster 3. Okay. So now if you divide into cluster 1A, cluster B, 1B, you can see first 3 point is coming in cluster 1A and rest point of the cluster 1 belongs to cluster 1B. Similarly, if you go for cluster 2, first 4 point of the cluster 2 belongs to, you can say, cluster 2A, and the remaining point of cluster 2 belongs to cluster 2B. Like in the 3A case, first 3 belongs to cluster 3A, next 3 belongs to cluster 3B. Now you may ask me how actually you have divided them into different clusters or subcluster. Cluster is obviously you based upon the class level, but what about subcluster? Okay, see here, if you go for cluster C1, C1 the members are x1, x2, x3, x4, x5. These are the 5 members, right? What is their x coordinate? Their x coordinate is 0 0.8. If we look into here, x coordinate is 0 0.8, 1.0, 1.2, 0 0.8, and 1.2. Right? If you take their average by doing 0 0.8 plus 1.0 plus 1.2 or 0 0.8, 1.2 divided by 5, you will get the value as 1.0. Similarly, if I take their y coordinate, it is 0 0.8, 1.0, 0 0.8, 1.2, and 1.2, and I'll calculate divided by 5 in order to find the average. I'll get the value is 1.0. So you can see mu1 is nothing but average x value and y value of each and every point. Okay, average value of all the points, right? C1 or C1 having 5 different points. So they are X average and Y average. Okay. Now let us consider the R1 is radius is assumed as 0.283. Similarly, in this case, you can calculate the mu2. Also, you can calculate in this case mu3, and radius is considered as 0.369. Here it is considered assumed as 0.528. Now, in order to calculate this B value, you can see in below the R1, we have written B1. So how to calculate this B1? So at the first level means this level. If you want to find the value of B1, it is nothing but the distance between the test pattern P and mu1. So the test pattern P is nothing but 3.0 and 2.0. Mu1 you have calculated is 1.0 and 1.0. Right? Now what you will do, if you calculate the distance between these 2 points, you will get the distance is 2.236. And what is your R1? R1 is 0.283. So you will get the B1 value is 1.953. Similarly, in order to calculate B2, what do you have to calculate? Distance of P2 mu2 minus the radius R2. You know, mu2 is nothing but your 4.11 and 3 minus the radius 2, which we have assumed as 0.369. If you do, then you get the B2 value is 1.125. In the similar manner, if you calculate the B3 value will get a 0.894. Now, since if you can see B1, B2, B3, which value is smallest? One value is 1.953. The second value is 1.125. The third value is 0.894. Which value is the lowest value or the smallest value? The smallest value is B3. So the subcluster of cluster 3, are searched. Why you have not decomposed C1 into two group, that is cluster 1A, cluster B, 1B, or cluster 2 to cluster 2A, cluster B, cluster 3 to 3A, 3B? Why you have not done? For cluster 1, cluster 2, why you have selected 3? That is the main reason is that in cluster 3 case, you got the smallest value. Right? Now, if you go for cluster 3, again you can calculate what is the mu value. Right? So, you can see there is a mu value here, mu 3A and mu 3B. So, we get the center for cluster 3A is 3.4, 0.533. And radius we have taken as 0.401. Similarly, mu 3B case, you got mu 3B is 3.83 and 0.9 by taking the points that is falling under 3B. Okay. Like if you see 3A case, X13, X14, X15. Okay. They are belongs to your cluster 3A. And last 3 points are belongs to cluster 3B. Now, what you will do here, the center of cluster 3B you found, center of 3A is found. You know the R value, you can calculate B value. B is nothing but the distance of P to mu 3A, that distance. Similarly, you have to calculate the distance of P to mu 3B. Okay, after calculating the distance, if you minus with the radius value, you will get the B value. So B value you found here is 1.12, 1.033. So which one is minimum? The minimum value is 1.033. So further you have to decompose C3B, not C3A. Okay. The region of breaking C3B is the B value is the lowest one in comparison to the cluster 3A. So the second subcluster of the cluster 3 is searched, and if you are searching for point 16, point number 16 is found to be the closest point of P. Right? Suppose you found which one is the closest point of P, and you found that the minimum value is 1.12. Right? In this way, you can apply the branch and bound algorithm, and you can reach to point 16, which is the point that is closest to point P, that is 1.1. So X16 is declared as the nearest neighbor of P. Okay. X16 is finally declared as neighbor B. You can see based upon 16 is belongs to class level 3. If you need the class level of this test pattern P, then you can consider 3 is the class level. Right? Now let us move to the next algorithm, that is called as queue algorithm. So in queue algorithm, assume that you have two classes. One is class 1 is having 6 different points starting from 1 to 6. Class 2 also consists of 6 points, and they are 7 to 12. So suppose it is required to find K nearest neighbor for P. Okay, this is your test pattern. You have to find K nearest neighbor where K is equal to 5. So in the previous case, if you remember R nearest neighbor algorithm, you have taken the radius R, and within that radius you found you are finding that what are the patterns belongs to within that particular radius. Right? Similarly, here what we are doing, we consider two conditions. One is P1, another is P2. Let's say the P1 condition says that it is 2 to 4. P2 condition is also 2 to 4. One you can consider in x-axis, another you can consider in y-axis. Like this is your 2, right? And this is your 4. And y-axis, this is your 2 and this is your 4. Okay. With this value, if you draw a rectangle, in this case we are getting a square. So you can see within this inner square, you found that how many elements are there? 1, 2, and 3. But what is your K value? K value is 5. If K value is 3, then you have to stop. But as K value is 5, okay, as K value is 5, so what you have to do? You have to slightly increase the value. Okay, let's say by 0.5, so that you can say 1.5, this value will decrease. 1.5 less than P1 less than equal to 4.5. I have increased in this side, decreased in this side. Here also 1.5 less than equal to P2 less than equal to 4.5. So you'll find this circle. This is your 1.5. This is your 4.5. This is your 4.5. So how many patterns are coming? Total 3 patterns already done. And here you are finding another 2 patterns. Now K is equal to 5. And what are the values? What are the patterns you are getting? You are getting 1, 4, sorry, not 1. You are getting 7, 5, 6, 7, 5, 6, and 4, 9, right? Now you can see 3 of them belongs to class 1. As 3 of them belongs to class 1, so you can say P is belongs to class 1. Okay, P belongs to class 1. Okay. Now coming to the second last algorithm, that is nothing but searching the nearest neighbor by projection. It is also a very important algorithm. So let us consider a test pattern P is equal to 3 and 2. Okay. Suppose you calculate again distance from P to X1, P to X2 up to P to Xn. Here n is 18. So we will find the Euclidean distance. And distance wise, if you find the order, if you look into the increasing order of their distance, you will find the order is x13, x14, x16, x7, so on up to x10. Okay, it is not showing all the patterns. We have taken only 11 patterns here. But if you continue like this, you will find all the patterns starting from x13, x14, x16, and so on. So we have sorted them in the increasing order of their distance. Now, let us go to this calculation so that it will be more clear. Yes, I have given this a calculation here. Now, what is x13? x13 is nothing but, okay, x13 is nothing but 1.61. Okay, x14 is nothing but 1.32. Okay, that we are calculating, you can see the order is based, this order of increasing is not based on the distance. The order is increasing order of the x value, right? So for example, if you see the x value, sorry, this one, x value, if you look into x13 x value, x13 x value, let me write here, x13, x14, x16, x7. I'll show you this for example. X13 x value is 3.2. 14 value is 3.2. 16 value is 3.5. 7 value is 3.8, and you will find an order. Now, if I calculate the distance, so distance of these points in x direction. So, what is the distance? 3.2, and the x point is 3 for the pattern P. So, the distance is 0.2. Here also distance you will get 0.2. Here you will get distance is 0.5. Here you will get the distance is 0.8, and so on. Right? But the distance from x13, which we have considered 14, 16, 7, 9, 15, 6, 17, 18, and so on, that is in this particular order. So try to understand, again I am repeating, we have ordered the x coordinates. As we consider first x coordinate, we have ordered the patterns in the increasing order of their x value. Once you have done this one, you found the difference, okay, between two different patterns, that is x13 x value and pattern P x value. X14's x value and pattern P value, you will get these values. But if you look into the distance wise, these are the distance. So in order to conclude, what you can do here, you have to find the distance from x60 1.61 to 1.32. Like here you can see the distance from x13 x14, you found this one. Starting from x13, the actual distance is checked and the minimum one is noted. So you see what is the minimum distance? X, this is 1.61 is the minimum distance. But when you look into 1.32, 1.32 is the minimum distance. When you look into 1.12, 1.212 is the minimum distance. When you go for 1.13, again 1.12 is the minimum distance. Go for this one, go for this one. Like that, if you go for each and every value, you will find 1.12 is the minimum one, which you have noted. So when x16 is reached, the minimum distance changes to 1.12. So when x18 is reached, okay, x18 is reached, the minimum distance changes to 1.12. Why you are looking over x18? Because x18 is the last one. Okay. So we have taken only the x coordinate to decide that whether the test pattern belongs to class level 1 or 2 or 3. As x18 is belongs to class level 3, so it is also belongs to class level 3. Okay. So the next point, x18 has a distance in the x direction. It is 1.2, which is the larger than the actual distance. Previously you found 1.12, right? If another distance you are getting, which is 1.2, you are not going to consider that, right? So it is not necessary to check any more point. X16 is the closest of P. So based upon the class level of X16, you can assign the class level to the test pattern P. Is it clear? Okay. The last algorithm is that is called as ordered partition, right? So here, instead of 18 different patterns in comparison to the previous example, here we have considered only 12 different patterns. Okay. Okay. So let us consider a point. The point is 777. Okay. And this point we want to search through the partitional data. Partitional data means initially you have to make a tree-like structure. That's why we call this a ordered partition. From the first value to the last value, you have to make a proper order so that when you search for a particular point P, you can easily reach to the point, okay, or reach to a particular pattern which is closest to the point P. So you can see here, like if you look into x1 and x2 or x3, x4 up to like x12, you can find the 12 patterns in the leaf node, right? Now, what we did here, when we make a search, you will start from the search here, right? First, you have to check that whether the first value lies in this range, which is minus infinity to 2.5, or it is in the range of 2.5 to 4.5, or it is in the range of 4.5 to 7. Okay. So you can see as the first value is 7, this criteria is not satisfied. This criteria is also not satisfied. The only criteria that it satisfies is in the range of 4.5 to 7. Now, if you go for the second branch or the sub branch of this branch, then you will find again two limit. One is minus infinity to 6.5, another is 6.5 to infinity. Right? But what is our second value? This 7. So it lies in the range of 6.5 to infinity, not in this range. So the second branch is chosen from the second dimension, which is 7. So you will get here the second dimension is 6.5 to infinity. Coming to third one case, the value is 7. Okay, 6.5 to infinity means either the point is either x11 or the point is x12, right? So x12 the value is 8, x11 the value is 6.5. So if you calculate the distance wise, you will definitely find the test pattern P is close to x11, not to x12. That's why x11 is chosen as the closest point. Okay, x11 is the closest point of our test pattern P. So if you follow these methods, like we discussed about branch bound method, Q algorithm, search for the NN by projection or ordered partition, you can increase the performance of nearest neighbor or KNN or MKNN or fuzzy NN or RNA. So this performance, as it is a time consuming process, this efficient method you can apply in order to get better result. So as a conclusion, what I can say, we have discussed the nearest neighbor algorithm. We have also discussed about several variants of the nearest neighbor algorithm. Then we have seen some of the efficient algorithms which you can apply in the nearest neighbor algorithm to improve its performance. Okay, so this is the reference. So thank you everyone. If you have any question, you can ask. Anyone having any question? Yeah, thank you everyone for patiently listening me. We'll close the session here. We'll start the next session at exactly at 5. Thank you everyone.
Thank you, Sanjay sir.
Yeah, welcome.
Okay, so we are going to start our session at 5 o'clock. Okay, sir. So good afternoon, all of you. Am I audible? Uh, Anyone will respond?
Yes, you are audible.
Okay. So, sir, so we are having now Santosh sir, Santosh Kumar Sahu sir. Sir, should we start?
Yes, please.
Okay, let me introduce you, sir. Santosh Kumar Sahu is working as a programming officer in OAL and Natural Gas Corporation (ONGC) Limited, India. He is currently working in Geo Data Processing and Interpretation Center (GEOPIC), a premium R&D institute in ONGC at Dehradun, Uttarakhand. He received PhD degree from NIT Rourkela, Odisha in CSC. He has 5 years experience in research on oil and gas industry and three experience in teaching. He has published many papers and reported in international and national journals and conferences. His research interests include cybersecurity, data mining, reverse engineering, and digital forensic. Welcome, sir.
Thank you, Deepak.
Okay, sir.
Good evening, all of you. This is Santosh Kumar Sahu from ONGC Dehradun. Am I audible?
Yes, sir, you are.
Okay. So today we will discuss some open source tools which are used to design machine learning prototypes. So, and I request you all to means if you have any doubt at any point of time, feel free to ask, and we will success this session. And means more interactively, we will discuss different topics. So let me present my slides. I think my slide is visible to you.
Yes, sir.
Okay. Thank you. So the objective of today's session is to learn different tools used for data analysis without coding, and selection of learning algorithms to address machine learning problems. And our prime objective is, as I said, we create different prototypes in a faster way. If you are a means Python lover, then this is the best session for you, because as Orange is implemented in Python, so it is fully compatible, and accordingly we will also design our own prototype using Orange, as well as we should extend our prototype to Python. So let's start today's session. So it is divided into four-part: introduction, tools used for data science, hands-on, and conclusion. As the definition of machine learning, uh, our prime objective is to find the hidden patterns and transfer information into knowledge, and improve that help us to improve the business decision making process. And uh, to for data analysis, we always use a concept that is course of dimensionality and less is more. We will discuss one after another, and we will not cover about big data analysis, which we means, restrict our discussion only data analytics. So this is the common workflow for data analysis, but we should skip here. Yeah, tools used for data science. As I said, no coding is required. So what kind of tools are available for data science? Having without means without a program, sorry, a student or a researcher or a faculty member should design their prototypes without writing a single line of code. Okay, so there are two types of code. One is commercial and open. Second is open source. So we will discuss one by one. In commercial category, you can see uh, uh, Oracle, SAS, W, SPSS Modeler, as well as your MATLAB. But as a researcher, we should emphasize on open source tools because it's open source and free. A lot of communities are help us to study, and also we also contribute something to the open source community using the open source tools. Due to that reason, these open source tools are nowadays very popular, okay, among the researchers as well as the students. And in industry also, we are also using this type of tools in R&D. So as I'm working in the R&D institute, we are also working with this kind of tools, as well as commercial tools are also available for our company. So we are also using commercial tools. But today we will discuss about Orange. It's a beautiful tool, and I will show you how to install Orange and how to design your prototype. That is your different classification techniques, clustering approaches, your image classification, test analysis. So many things we have to discuss. We have to discuss one after another, and please help me to asking more and more question and clearing your doubt. Okay. So I'm just also sharing some other tools. Another tool is your Rattle, and if you are a R coder, means R lover, so you can go for Rattle. And Rattle also, without coding, you can design your machine learning protocols. Similarly, if you are a Java programmer, then you should go with Weka. Weka is also a very good tool, and it is so much popular, and it supports deep learning approaches also, and a huge amount of libraries are also available in Weka, and you can write Weka code. Sorry, you can write your Java code using the Weka API, and you can directly interact with Weka platform with Java. But if you are a Python lover, then you should go for Orange, because Orange is fully compatible with Python, because it is implemented in Python. So or if you are a Python coder, then you should go with Orange. So as you know, nowadays in BTech and MTech syllabus, Python is compulsory. So we all know Python. So better we should know about Orange. Okay. So let's show some concepts of Orange and how we can uh, download Orange and installation. There are different installation type. Just I'm going to show you. In Google, you simply type data mining using Orange. I'm just typing. If you are not if my browser is not visible to you, please let me know. So here you go to orangedatamining.com. And the beauty of this tool is, you just see, you go to download and you check. It supports cross-platform, means if you are a Windows user, Mac user, or Linux user, no problem. It can supports all OS, all major operating systems, and it also supports some portable edition, means without installation also you can working with Orange. Suppose consider a scenario in your university machine or in your college machine. Suppose you have no administrative privilege, then also you can install Orange in your machine and use it. Okay, no administrator privilege is required, and also without installation of Orange, you can also download the portable edition and you can start working on it. Okay, so this is the beauty of this tool, and no need to write any means single line of code. If you know Python, it's good. If you don't know Python, no problem, you can working with Orange. And as it's already just in your Orange website, They have given how Orange is helpful for teachers and students, how it provide your visual programming tool to design your prototypes. Similarly, how you can also use these add-ons, and it's also known as widgets, to create and deploy your models. So if you see this screen, it is applicable in Windows, Mac, as well as Linux. Okay, and if you go with this portable Orange, that means no need to install the Orange. You can start Orange with your pen drive also. Okay, hard disk or pen drive also, external hard disk or pen drive also. Okay, so in your, suppose you are you wish to use Orange in your college machine, you can also do that. Okay, so and uh, see, you can read this. It can be used without administrative privileges. This is the beauty of this tool, because during installation, your administrative privilege is required, but in case of Orange, there is no administrative privilege is required. Okay, and you simply go with this download Orange, or you can download the portable edition. Okay, I have already downloaded. See, this is the dashboard of Orange. Hope you able to see this dashboard of Orange. And if you, I just zoom it. See, if you see this is different means these are known as widgets. Okay, data sampler, select column, data file, CSV file, or are known as widget. एंड ये जो widget है आप देख सकते हैं, they are categorized as per their application. For handling data, some widgets are used like file, CSV import, data sets. Okay, if you and how to use this, you simply double click here or drag and drop here. Okay, in both ways you can working with this widget. See, suppose we use a CSV file in our project, you simply drag and drop the CSV widget. Okay, and now you can working with this file, you simply double click and then you browse your data file. Suppose I will use this data, simple data. Where is the simple data? Double click, then you can preview your data. See, this is the window where you can preview your data. Okay, I just zoom out to show you the whole screen. See, here you can preview your data, and then if you press OK, then the data is imported. Okay, then this will simply close. Or in another way, by using the file widget, you can do that. So this is all about widgets. Means suppose you are going for image classification, then these are the widgets which are used in image classification. Suppose you are going for some unsupervised approaches in your model, so these are the unsupervised widgets which are used to design your prototype. So in this way, you can design different machine learning models using these widgets. Okay, and another important thing is, if you just install Orange, then the whole widgets, whole categories like transform, visualize, model, evaluate, unsupervised, यहाँ तक तो आपको आ जाएगा. एंड बाकी जो है नीचे जो आ रहा है, सी यू सी इमेज एनालिटिक्स, टेस्टेबल, टेस्ट माइनिंग, नेटवर्क्स, एजुकेशनल, टाइम सीरीज, these categories may not be available. So how to avail that? For that, you go to option, click on add-ons, then you just select your widgets by using the checkbox. You just check and you install your required widget. Okay, then automatically that category comes here in your dashboard, and now they are ready for your means ready to address your different problems. Okay, see, this is the window where you can add, and it supports many types of problems like associate mining, your bioinformatics, educational, explain geostatic. So many things are available, but as per your requirement, you select the widget and use. Okay. And the most beauty of this tool is if you go for Python or another way to select is you simply right click in the canvas. This part is known as canvas. Okay, your working area. You can say that this is working area. See, this is working area, and this is your toolboxes. Like in your Visual Studio, it is known as toolbox. Okay, and here it is known as widgets. Okay, so different widgets are available here, and as per our requirement, we select the widget and using that widget in our modeling. Okay. Any doubts so far? Please ask. At any point of time, if you have any doubt, please ask. Feel free to ask. And if you have your own data, you can also share with me. We can lively analysis your data and show the result. Okay, we will discuss different results, possible results using your own data. Or you can after ending of this session, you can also able to perform different modeling using your own data. It's quite simple and it will very helpful for modeling your earlier approaches. कुछ काम जो रिसर्चर लोगों ने किए हैं उसको आप मॉडलिंग करना सपोज इम्प्लीमेंट करना चाह रहे हैं तो विद इन शॉर्ट स्पान ऑफ टाइम यू कैन इम्प्लीमेंट दैट. ओके, सो इसीलिए आप ये टूल को यूज कीजिए किसी और का काम को इम्प्लीमेंट करने के लिए. एंड इफ यू try to implement your own work, then you initially you can working with Orange, and then you can use Python to complete your proposed approach, and then if you have face some problem, then you can also use Orange. But I recommend you for your proposed approach you go with Python. Okay, so let's start today's discussion. As we know in data mining, any question? Not able to see. If you have any question, please ask. Can you use it with PostGIS for spatial data? हम कभी यूज नहीं किए हैं, but hope it will. Data, if you show me the data, then I मैं कभी काम नहीं किया हूँ इसके ऊपर, but if you share the data, then we can working with it. Okay, no problem. See, data, if you able to convert the data in a tabular form, then this tool for you. Okay, it may be image, it may be Excel sheet, or it may be a textual format or unstructured format. The first and foremost thing is you have to convert your data into tabular format because it supports tabular format. Okay, and if you have images, I will show you. Suppose we have images, then how to convert images into tabular format. Okay, sir. So we will discuss one after another. Just let me show you the first step, data pre-processing. So as we have studied in our data mining and machine learning syllabus, the first step is your data cleaning. Okay, and in data cleaning, the first step is missing the impute the missing values. Okay, missing value imputation or fill the missing values. So we just take a file widget, then we connect. I just zoom it, that can be visible to you. Yeah, you take a file widget, then connect with simple data. Okay, see, simple data, it is connected, and here see, as we have discussed in my slide, I have not just show and I click next. As in machine learning techniques, as we know, we divide the data into two part. One is your X and second is your Y, where X is the feature set and Y is your target class. In the similar fashion, here also you divide your data into two types. See, here X1, X2 and X3 are the set of features, and Y is your target. You can also change. You can change target to feature as per your requirement. Okay, सपोज आपके डाटा में ये टारगेट शो नहीं कर रहा है, तो यू कैन मैनुअली सेट योर फीचर एज टारगेट. Okay, but in this case it is automatically detected. Okay, click apply, then close here. Now to preview the data, we should use a data table. If I double click here, then you can see this is my y followed by x1, x2 and x3. That means इसमें हमारा 3 फीचर सेट है and the features are x1, x2 and x3 and y is your class level, right? तो इसमें हम देखेंगे कैसे कि कैसे फीलिंग वैल्यू मिसिंग वैल्यू है या नहीं. ओके, सो फॉर दैट यू कैन सी हियर, आई जस्ट मैग्निफाई. You see, in the info part, it is showing 45 instances, 3 features. That is 2.2% missing data is available. Okay, and numeric output and no meta attributes are available. That means in this data set, some missing values are there. So it is our first duty to fill the missing values. Okay, either you fill or remove the rows which contains missing value. So आप हटा सकते हैं if you have a large amount of sample size. जैसे यहाँ पे सपोज आपका 45 इंस्टेंस है and out of 45 if you delete 2.2% means सपोज आप 2 इंस्टेंस रिमूव करना जा रहे हैं तो you lose your data. Okay, so better you try to fill the missing value and then you go for modeling. तो आपका मिसिंग वैल्यू इम्पुटेशन का आउटपुट कैसा आ रहा है, यू कैन ऑल्सो चेक. यू कैन इवेलुएट योर आउटपुट and before missing value what is your output and after input the missing value what is your output. Okay, output you can output आप कैसे देख सकते हैं ना, you can check your output using ट्रेनिंग एरर. आपका ट्रेनिंग एरर सपोज मिसिंग वैल्यू जब होता है कम आता है एंड जैसे ही हम मिसिंग वैल्यू फिल कर दिया ट्रेनिंग एरर और कम हो गया है, दैट इज बेनिफिट फॉर अस. सपोज ट्रेनिंग एरर बढ़ गया है, दैट मीन्स there is some problem in our imputation approach. Okay, so either we change the approach or you go with go by delete the instances that contains missing values. Okay, so अभी हम देखेंगे कि ग्राफिकल वे में आप कैसे इसको चेक करेंगे. सो आई जस्ट जूम आउट. तो ग्राफिकल वे में इसको करने के लिए देयर इज ए widget that is a line chart. So data to time series. Okay, see here you connect data to time series. Okay, then press OK. If you see, just I double click here, you see I am visualizing the x1, x2, x3 and y. Okay, आप देख सकते हैं यहाँ पे देखिए there is a discontinuity. That means there is a gap. इसमें gap है means data नहीं है, right? Similarly, in case of x2, you can also check there is a gap here. Line देखिए टूट गया, 2 पार्ट में डिवाइड हो गया है. That means there is a gap. That means some missing values are present. But in case of x3, see there is no missing value. ठीक है, and y में भी कोई missing value नहीं है. That means what is our means our first duty is how to fill the missing gap or how to fill the how to impute the values of the missing cells. तो इसको कैसे करेंगे, now we will discuss. तो ऑरेंज कैसे हमें ये सपोर्ट करता है तो हम देखते हैं. You connect the data table. You connect the data table with impute widget. There is a widget known as impute. Okay, and here if you see here, I just magnify. See, यहाँ पे आपको दिया जा रहा है कि डोंट इम्प्यूट. दैट मीन्स आपको इम्प्यूट करने का जरूरत नहीं है. यू गो विथ द ओरिजिनल डाटा, एवरेज और मोस्ट फ्रीक्वेंट. एज ए मीन्स जो एवरेज वैल्यू निकाल के जो वैल्यू होगा उसी में वो रिप्लेस कर देगा. थर्ड है कि एज ए डिस्टिंक्ट वैल्यू, आप कोई भी एक वैल्यू पुट कर सकते हैं. सो एज पर डिफरेंट मीन्स डिपेंड ऑन योर वर्क. जैसे हम साइबर सिक्योरिटी में इसको काम करते हैं एंड सपोज मुझे देखेगी एक डॉस अटैक है, तो डॉस अटैक में प्रोटोकॉल, सपोज प्रोटोकॉल फील्ड में कुछ मिसिंग है, तो प्रोटोकॉल में कभी भी डॉस अटैक के लिए आईसीएमपी नहीं होगा, या होगा, या टीसीपी हो सकता है, या यूडीपी हो सकता है। तो ये जो एनालिसिस, ये आपका सब्जेक्टिव एनालिसिस में ये सब आ जाएगा, डिस्क्रिप्टिव एनालिसिस से। तो सपोज आप देखेंगे कि हाँ नहीं ये इधर टीसीपी होना चाहिए या आईसीएमपी होना चाहिए, यूडीपी नहीं होना चाहिए। सो इधर वी फिल विथ टीसीपी और वी शुड फिल विथ यूडीपी। तो इसीलिए ये थर्ड ऑप्शन इज अवेलेबल। ओके, आप खुद आपका वैल्यू सेट कर सकते हैं, और यू कैन ऑल्सो गिव ए फिक्स्ड वैल्यू एज पर योर रिक्वायरमेंट, और यू कैन गो विथ ए मॉडल बेस्ड इम्प्यूटर। सिंपल ट्री हो, यहाँ पे सिंपल ट्री दिया है, बाकी सपोज आप सपोर्ट वेक्टर बेस्ड यूज करना चाहेंगे या कोई अदर अप्रोच यूज करना चाहेंगे, वो भी यू कैन डू दैट। और इफ यू गिव सम रैंडम वैल्यूज यू कैन डू दैट। और द मोस्ट इंपॉर्टेंट ऑप्शन है रिमूव इंस्टेंसेस विथ अननोन वैल्यूज। सो इसको हम एक्सरसाइज कब करेंगे? इफ वी हैव ए लार्ज वॉल्यूम ऑफ डाटा। सपोज हमारा पास 10 लाख सैंपल है, तो उसमें हमने देखा कि 2000 सैंपल में मिसिंग वैल्यू है, वी सिंपली रिमूव देम। Okay, no need to go with imputation approach. Okay, so if our sample size is very large, then you can remove the instances with unknown values. Okay, but उसमें भी आपको देखना पड़ेगा क्लास डिस्ट्रीब्यूशन। सपोज हमारा पास 10 लाख इंस्टेंस है, सैंपल साइज हमारा 10 लाख है, बट 9,75,000 हमारा एक क्लास को बिलोंग करता है, बाकी जो 25,000 है वो 10 क्लास को बिलोंग करते हैं। तो उस केस में सपोज माइनॉरिटी क्लास को जो बिलोंग करता है डाटा, सपोज उसमें मिसिंग वैल्यू है, सो वी शुड नॉट गो विथ दिस ऑप्शन। ओके, सो एज पर योर प्रॉब्लम you can exercise the options. Okay, and here for demonstration purpose I will go with this option, model based imputer, and I click on apply. Any doubt, please feel free to ask. Another important concept, suppose आप मुझे पूछ सकते हैं कि संतोष, can we go with individual columns with a particular approach? Yes, you can do that. आप सपोज x1 फीचर में कुछ पर्टिकुलर मेथड अप्लाई करना चाह रहे हैं, x2 में कुछ और करना चाहते हैं, x3 में कुछ और करना चाहते हैं, यू कैन डू दैट। x1 में सपोज आई विल गो विथ एवरेज अप्रोच, एंड x2 सपोज आई विल गो विथ मॉडल बेस्ड इम्प्यूटर। you can achieve this, no problem, and click apply, it will work. Okay, so as per your requirement you can select the option. Okay, any doubt, please ask. After that, what to do? You simply take a data table to preview the output. I simply double click here and just magnify to show you the information part of the table. Here you can see 45 instances, no missing data. That means we successfully imputed the missing values using two approaches. As I have showed you, one is in X1 we have used a most frequent approach, and in X2 we use model based imputer using simple tree approach, decision tree. Okay, right. सपोज आप बोलेंगे नहीं मुझे ग्राफिकली देखना है कि आउटपुट में आपने जैसे दिखा रहे थे कि लाइन चार्ट यूज करके वैसे देखना है कि वेदर देयर इज सम डिसकंटिन्यूटी इज अवेलेबल और नॉट। सो यू कनेक्ट डाटा विथ टाइम सीरीज, देन प्रेस ओके, एंड इफ यू डबल क्लिक you can see, I just zoom out, you can I add plot x1, this is for x2, this is for x3। तो पहले जो हमारा प्लॉट था, देखिए ये है पहले का जो प्लॉट था, दिस इज आवर अर्लियर प्लॉट, द डाटा विथ मिसिंग वैल्यू, एंड दिस इज द प्लॉट डाटा विथआउट मिसिंग वैल्यू। सी आप देख पा रहे हैं आई थिंक। सो यहाँ पे देखिए देयर इज नो डिसकंटिन्यूटी। सिमिलरली यहीं पे भी जो मिसिंग वैल्यू था वो आपका कैलकुलेट हो गया है। ओके, सो इन दिस वे यू कैन इम्प्यूट द मिसिंग वैल्यू ऑफ योर डाटा सेट, वट एवर मे बी योर फील्ड। जैसे सर ने अपना फील्ड के बारे में बताया, और जो फैकल्टी रेस्पेक्टेड फैकल्टी मेंबर है उनका भी डिसिप्लिन अलग अलग है, नो प्रॉब्लम। You simply export your data in CSV TSB format, and you play with your data. Okay, and if you face any problem, you can contact me anytime. Okay, no problem. So see, here you can easily fill the missing values. Right now, after impute the missing value, what should be our next step? As per data mining and data cleaning approaches, the next step is how to deal with duplicate records. That is also a headache. सपोज आपका डाटा साइज बहुत ज़्यादा है एंड उसमें डुप्लीकेट एलिमेंट्स आर देयर, तो हाउ टू डील विद द डुप्लीकेट डाटा. So for that you go with some string matching algorithm to match, means you consider a row as a string and you check with the whole list or whole table, or you can go with a unsupervised approach. I am just showing you one by one. Just we will take a simple data set. मैंने जानबूझ के एक डाटा बनाया हूँ, देखिए. जस्ट आई एम गोइंग टू शो यू ब्राउज डुप्लीकेट क्लोज. सॉरी, इसमें duplicate. Then I will connect this file widget using a data table, and now we can preview here. आप देख सकते हैं यहाँ पे there are how many rows are available? Around 19 rows are available, means 19 records are available in this data. And how many features? There are 3 features. Okay, and it is showing you, see, 19 instances, no missing data, 3 features. That means no target variable is available and no meta attribute is available. जैसे मैंने आपको बताया था कि target variable which is commonly known as y is not available, then you can set your target, forcefully set your target variable. So हम इसको कैसे करेंगे? I am just showing you. इसको डबल क्लिक करना है and here you can set your target variable like this. Okay, apply. Just for information I am showing you. See, now it is showing you target with 4 values. That means जो target class है, तो there are 4 classes available. Okay. So there are 4 distinct classes available in this data set, right? Okay. और क्या जानना है ना? What about the duplicate records? So इस पे डुप्लीकेट आप देख के ही पता चल जाएगा. संतोष, संजय, जितेंद्र, ये बार बार आ रहा है. Okay, but if your dimension is large in real data sets, the dimension is high. So at that moment, as a human being, we can't distinguish the duplicate records. यहाँ पे तो एक नाम आ रहा है, आप इजीली रिकॉग्नाइज कर पा रहा है ह्यूमन, जैसे हम लोग कर पा रहे हैं कि हाँ संतोष रिपीट हो रहा है, जितेंद्र रिपीट हो रहा है, संजय रिपीट हो रहा है. ओके, बट एज रियल डाटा सेट में आप नहीं कर सकते. तो उसको हम कैसे करेंगे? जस्ट आई एम गोइंग टू शो यू. सो व्हाट टू डू, देयर इज ए विडजेट प्रेजेंट यूनिक. देखिए कितना आसान है ये. जैसे हम लोग काम करते हैं ना डिफरेंट एरिया में, तो ये जो विजुअल प्रोग्रामिंग में करना बहुत आसान है. यू कैन design your prototype within 5 minutes. Okay, and you can also see your output within 5 minutes. And after that, if it okay, good, if you are satisfied, then you implement in Python for more in-depth analysis. See, you connect this unique widget with data table. Now if you click here, so in original data set there are 19 instances are there, but right now we have only 5 instances. आप बोल सकते हैं संजय तो डुप्लीकेट है. नहीं, यहाँ पे देखिए रोल नंबर एक संजय का 2 है एंड सेकंड संजय का 6 है. एंड एज ऑल्सो, one is 30 years old and second is 90 years old. Okay, so in this way we can eliminate the duplicate records from a data set. Any doubt? Please ask. डाउट नहीं है, आप पूछिए. ये सब बहुत कम सेशन में ये सब डिस्कशन हो रहा है and you are so lucky. I am here to answer your question. If you don't ask, it's upon you. Okay, thank you.
हेलो सर।
Next, हाँ प्लीज आस्क।
सर एक क्वेश्चन था
प्लीज पूछे मैम।
सर, जैसे नेम वाला फील्ड को हमने यूनिक किया, कैन अदर फील्ड्स बी मेड यूनिक?
हाँ, नहीं अभी नेम को नहीं किए पूरा। एक्चुअली जैसे मैंने आपको बताया था कि ये तीनों को वो कंसिडर किया है एक स्ट्रिंग। संतोष 1 and 30 मीन्स तीनों फील्ड जो है नेम, रोल नंबर एंड एज, तीनों को लिया है। ठीक है मैम, एक को नहीं लिया है। ओके,
सबको को कंसीडर किया है सर पूरा?
हाँ तीनों को इट्स ए सिंपल स्ट्रिंग मैचिंग अप्रोच। ओके
ओके सर।
ओके, थैंक यू। ओके, आप पूछ सकते हैं कि ये तो हो गया स्ट्रिंग मैचिंग, इधर एनी अदर अप्रोचेस आर अवेलेबल? यस, द अप्रोच इज, हम लोगों ने पढ़े हैं डाटा माइनिंग में कि एक डिस्टेंस मैट्रिक्स है, L1 distance, L2 distance, Euclidean distance, Manhattan distance, so many distance measures are there, उसको similarity measure भी बोलते हैं। तो उसमें भी हम इसको यूज कर सकते हैं। तो सिमिलरिटी मेजर में क्या होता है, क्लस्टरिंग में हम पढ़े हैं कि सपोज ए इंस्टेंस इज द डिस्टेंस बिटवीन टू इंस्टेंस इज 0 इफ दे आर आइडेंटिकल। ओके, उसी कॉन्सेप्ट को हम यूज करके भी कर सकते हैं। देखिए कहाँ से क्या कैसे डिस्कशन मीन्स जो हमारा ऑब्जेक्टिव है वो फुलफिल हो रहा है। क्लस्टरिंग अप्रोच में हम पढ़े हैं कि इफ two instances are identical, then they are present within one cluster and the distance should be 0. हमें तो यही चाहिए। ठीक है, so let me show you how to accomplish same task using unsupervised batch approach. So for that we should take help of a distance widget and connect the distance widget using duplicate detection or using a distance matrix, then connect here this. See, so here you can see जैसे कि हमारा जो आ रहा था यहाँ पे डिस्टेंस मैट्रिक्स में, आई थिंक देयर इज सम प्रॉब्लम। बट द प्रॉब्लम आप देख सकते हैं यहाँ पे सिलेक्टेड डाटा टू डाटा आ रहा है। सो बेटर यू सिलेक्ट डाटा टू डाटा, ओके, and here also you select data to data, it is benefit for us। okay, otherwise suppose आप selected data ये करेंगे, ठीक है, तो यहाँ पे आपको सिलेक्ट करना पड़ेगा सारे डाटा को। यहाँ पे you select all, then it's okay, but आप भूल जाएंगे तो पार्शियल डाटा ही आएगा। so better you select data to data। now you see the distances, and जैसे मैंने आपको बताया था ये सारे डिस्टेंस मेजर है, यूक्लिडियन, मैनहट्टन, कोसाइन, सो मेनी अप्रोचेस आर देयर। ओके, नहीं है तो यू कैन आल्सो इम्प्लीमेंट। देन यू चेक द डिस्टेंस मैट्रिक्स। यहाँ पे देखिए डायगोनल में सब 0 आ रहा है। ओके, ये तो 0 आएगा, बट व्हाट अबाउट द अदर्स? ये देखिए इंस्टेंस नंबर 1 and instance number 5, the distance is 0, you can check। that means instance number 1 में जो है वो 5 में भी वही है, they are identical, so we should remove 5। similarly instance number 9 में भी सेम है तो we should eliminate 9। similarly 13 में भी सेम है, 0 आ रहा है। जहाँ जहाँ आपका डिस्टेंस मेजर 0 आ रहा है that means they are repeated। ओके, तो वहाँ पे हम उसको सिंपली डिलीट मार देंगे। ओके, सो इन दिस वे ऑल्सो बहुत सारा अप्रोच है, तो आप उसको ये कर सकते हैं। टाइम नहीं है तो इसलिए आप 1 by 1 आप एक्सप्लोर कीजिए। ठीक है, एंड इफ यू कनेक्ट द डुप्लीकेट डिटेक्शन यूजिंग ए डाटा टेबल, देन यू कैन सी corpus to data, corpus without duplicate, yes, okay, and यहाँ पे distance to distance, data to data, okay। why one instance is coming, it should be just check। यहाँ पे तो हमने 13 दिए हैं, ठीक है, एंड डिस्टेंस भी कितने आ रहा है यहाँ पे डिस्टेंस मेजर में, अराउंड 19 आ रहा है। ओके, इट्स ओके, and we can also direct connect this to this। okay, no need to distance matrix, we should directly connect the duplicate detection with डिस्टेंसेस. ओके, एंड फॉर मोर मीन्स और जानकारी के लिए हमने ये आपको दिए थे डिस्टेंस मैट्रिक्स, कि यहाँ पे आप यू चेक द डिस्टेंस बिटवीन टू इंस्टेंसेस. ओके, ये मैट्रिक्स आपको सारे बता दे रहा है कि कहाँ कहाँ डुप्लीकेट वैल्यू है. बट if you try to eliminate the duplicate instances, then you connect distances with a duplicate detection and connect a table with the duplicate detection. Now you can check same result is coming. Okay, जो हमें यूनिक दे रहा था वही रिजल्ट हमें अनसुपरवाइज्ड बेस्ड अप्रोच में मिल रहा है. That is our objective. Okay, so in this way you can eliminate the duplicate records from your data set. Any doubt, please feel free to ask. नो डाउट, गुड. उसके बाद क्या है ना, नेक्स्ट टॉपिक टू बी डिस्कस इज योर एनोमली डिटेक्शन, और इसको बोलते हैं आउटलायर डिटेक्शन. हाउ टू डिटेक्ट द आउटलायर्स. ओके, आई थिंक समवन इज राइट क्वेश्चन. आई थिंक नो डाउट, थैंक यू. सी, आउटलायर कैसे हम डिटेक्ट करें. ओके, बहुत सारा लिटरेचर में है कि इट्स ए वेरी टफ वर्क. आप किसी को भी पूछिए कि हाउ टू डिटेक्ट द आउटलायर्स, ही और सी में बी नॉट आंसर. आउटलायर क्या है तो सब बता देंगे. तो इसको इजीली हम कैसे ये करेंगे, देखिए, जस्ट आई एम गोइंग टू शो यू द डेमोन्स्ट्रेशन. आई सिंपली डिलीट इट. नाउ सी, इन आवर डाटा सेट वैल्यू तो मिसिंग वैल्यू तो फिल हो गया है. अभी हम देखेंगे कि whether this data set contains some outlier or not. तो outlier are the exceptional values. Sometimes they are treated as not worthful, but sometimes it is worthful. Okay, and you can't say it is unwanted values. जैसे हम साइबर सिक्योरिटी फील्ड में रिसर्च कर रहे हैं तो आउटलायर आ रहा है टैक्स. जो भी आउटलायर आ रहा है वही अटैक होता है. ठीक है, मैक्सिमम केस में. बट इन केस ऑफ अदर डिसिप्लिन ऑल्सो इट डिपेंड्स. ओके, आप नहीं बोल सकते कि आउटलायर आर नॉट रिक्वायर्ड एंड वी शुड एलिमिनेट द आउटलायर्स. बट आउटलायर हम कब देखेंगे, जैसे कि आपने एक मॉडलिंग किया है, एक डाटा आपको मिल गया है, आपने डाटा ट्रेनिंग कर दिया है, एंड मॉडलिंग जब कर रहे हैं, ट्रेनिंग में देखिए आपका ट्रेनिंग एरर है जो वो ज़्यादा आ रहा है. That means the model is not able to fit or not properly learn from your data. तो उस केस में आप देखेंगे कि मुझे डाटा प्री प्रोसेसिंग में ही कुछ करना पड़ेगा. Whether you go a advanced or complex model, still you get some training errors. क्योंकि हमें पता है कि training error we should model our data with an objective of training error is 0. Okay. बट सपोज आपको कुछ आ रहा है, ट्रेनिंग एरर जैसे आ रहा है कि 10%, 5%, विच इज नॉट एक्सेप्टेबल. ओके, इट शुड बी बिलो 1%, देन इट इज एक्सेप्टेबल ड्यूरिंग ट्रेनिंग फेज. एंड ड्यूरिंग टेस्टिंग फेज इट डिपेंड्स. सो उसमें आप देखेंगे कि ड्यूरिंग ट्रेनिंग फेज व्हाट अबाउट माय ट्रेनिंग एरर एंड हाउ माय मॉडल लर्न फ्रॉम द डाटा. दैट इज मोस्ट इंपॉर्टेंट. ओके, तो इन दिस केस यू कैन सी देयर इज ए सडन स्पाइक. यहाँ पे देखिए बहुत ये जो वैल्यू है पूरा ऊपर जा रहा है. देयर इज ए सडन स्पाइक और द हाई वैल्यू इज recorded here. Similarly, in case of X2 we receive same signal, high signal here. यहाँ तक देखिए वैल्यू बहुत कम आ रहा था, यहाँ पे सडन देयर इज ए स्पाइक, बहुत हाई वैल्यू आ रहा है. एंड ये एक्सेप्टेबल है, ये जो स्पाइक है इट इज एक्सेप्टेबल, बट दिस इज नॉट एक्सेप्टेबल. तो इसको आपको देखना पड़ेगा एक्चुअली ड्यू टू सम ह्यूमन एरर और ड्यू टू सम मशीन एरर ये आ रहा है, या दिस इज ए अटैक. जैसे हम साइबर सिक्योरिटी में हम इसको बोलते हैं अटैक, ये अटैक हो सकता है. इट में बी ए डॉस अटैक. ओके, क्योंकि डॉस में आपका रिक्वेस्ट बहुत ज़्यादा आता है एक पर्टिकुलर आईपी एड्रेस से, तो ये डॉस अटैक हो सकता है. बट इन केस ऑफ अदर डिसिप्लिन इट मे नॉट बी अटैक और इट इज नॉट, इट इज अनवांटेड वैल्यू. सो बाय यूजिंग outlier detection approach we should normalize the data, we should eliminate the outlier or we should normalize the data. Now I am going to show you how to do that. Okay, and यहाँ पे देखिए X3 में यहाँ पे sudden spike है, but it is also somehow acceptable, but these two X1 and X2 it is not acceptable. Okay, तो इसको हम कैसे एड्रेस करेंगे जस्ट हम आपको बताना जा रहे हैं. एनी डाउट आप मुझे पूछ सकते हैं, यू कैन आस्क मी एनी डाउट इफ यू हैव. तो सी हाउ टू डू दैट. We simply connect this data table with a outlier widget, right? And you here you double click and select data to data, not selected data to data. Okay, then again you select this outlier into a data table, and यहाँ पे आपको पूछ रहा है see inliers, outliers and data. So better you select inliers. You can also select outliers, no problem. You can select both also. Okay, but it is better to select inliers, and you rename the table as inliers for clarity. Okay, and you can also separate the outliers using another table. You connect outliers to data. Okay, and you rename the table as outliers. ये आपका आउटलायर है. कितना इंस्टेंस आउटलायर है देखिए, 1 2 3 4. देयर आर 4 आउटलायर्स एज पर द डिफॉल्ट अप्रोच, एंड इनलायर्स रिमेनिंग आर द इनलायर्स. ओके, नाउ हमारा आउटपुट सही आ रहा है नहीं आ रहा है वो भी चेक करना है ना. जैसे मैंने आपको बताया था कि यू कनेक्ट दिस टेबल विथ ए लाइन चार्ट, वही स्पाइक हम देखेंगे. एंड यू सिलेक्ट डाटा टू टाइम सीरीज, प्रेस ओके. नाउ यू डबल क्लिक हियर. सी पहले जो आ रहा था देखिए, जो पहले का डाटा आ रहा था, दिस इज द इनिशियल डाटा एंड दिस इज आवर डाटा विदाउट आउटलायर्स. ओके, एंड इसको आप कंट्रोल भी कर सकते हैं. ऐसा नहीं कि यही आ रहा है एंड आप कुछ नहीं कर सकते. यू कैन ऑल्सो कंट्रोल. आउटलायर में डबल क्लिक कीजिए जस्ट, एंड ऑरेंज देखिए आपको कितना बढ़िया से ये दे रहा है, GUI बेस्ड एनालिसिस दे रहा है. मैं इसको भी सिलेक्ट किया. यू कैन लाइव एनालाइज मीन्स एनालिसिस योर डाटा. Then I will go with this. See here my approach is local outlier factor. There are 4 approaches are available. First is one class SVM, second is your covariance, third is your local outlier factor, and fourth is your isolation forest approach. आप देख सकते हैं यहाँ पे एक प्रोग्रेस बार है. यहाँ पे आप सिलेक्ट कर सकते हैं contamination. This is the most important part. Here we assume that 10% डाटा में भी आउटलायर. आप इसको 0 कर देंगे, दैट मीन्स ओरिजिनल डाटा जो आपका था वही चला जाएगा. सो बेटर यू सिलेक्ट द कंटामिनेशन एज पर योर रिक्वायरमेंट. सी हाँ, यहाँ पे हम क्या करेंगे, दोनों को x1 एड प्लॉट, x2 एड प्लॉट, x3 तीनों को शो करेंगे जैसे यहाँ पे शो हो रहा है. ठीक है, नाउ सी वी सिंपली इंक्रीज द. देखिए x1 का तो हो गया फिक्स, देयर इज नो सडन स्पाइक, बट व्हाट अबाउट x2? x2 का कोई नहीं, अभी तक फिक्स नहीं हुआ है. सो वी सिंपली इंक्रीज द कंटामिनेशन टू 2% to 4%. नाउ यू कैन सी यहाँ पे 2 स्पाइक हो रहा है, ये भी नॉट एक्सेप्टेबल. यू सिंपली इंक्रीज 4 to 9%. देखिए यहीं पे x1 एंड x3 जो ओके, बट x2 देयर इज ए सडन स्पाइक, इट इज ऑल्सो नॉट एक्सेप्टेबल. धीरे बढ़ा दीजिए 10. नाउ इट इज एक्सेप्टेड. दिस आंसर इज एक्सेप्टेबल. सी here there is no sudden spike. okay, तो इसको बोलते हैं outlier detection using orange. And you can also change different approaches. This is the output using isolation forest. You can change to one class SVM. This is the one class SVM, and the output is not impressive, and so you have to increase the contamination. आपको इसको धीरे धीरे बढ़ाना है या घटाना है. ठीक है, you can increase or decrease the contamination. Similarly, in case of local outlier factor, you can check, you can increase or decrease as per your requirement. See, now it's okay. When it is 11%, the output is acceptable. So in this way, you can perform outlier detection approaches using your data. Okay, and orange में 4 दिया है, 4 is enough. And you can also select different distance measures. Okay, different distance measures present in orange. Okay, so L1, L2, cosine, Jaccard, so many, around 6 approaches are available. You can select as per your requirement. आप नहीं बोल सकते हैं कि L1 that is Manhattan is best. No, it depend on your data. आपके डाटा में सपोज काम हमारे डाटा में काम कर रहा है, आपका डाटा में it may not perform better. Okay, so your answer should be it depend on the data. Okay, Any doubt? Please ask. Then ये तो विजुअली आपने देख लिया, एंड टेबुलर मैनर में भी यू कैन ऑल्सो सी योर डाटा. सी दिस इज अ टेबुलर डाटा, एंड ये डाटा को लेके यू कैन गो विथ फर्दर एनालिसिस. जो भी आपको आगे मॉडलिंग करना है यू कैन डू दैट. बट जैसे मैंने आपको बताया था कि आउटलायर डिटेक्शन इज द थर्ड अप्रोच. देन व्हाट अबाउट द फोर्थ? द फोर्थ वन इज फीचर एनालिसिस. Normalization, data normalization. So Orange provide you a widget, namely pre-process. Okay, and in this pre-process, as I said, the connection type should be data to data. And in pre-process widget, you can see in normalize options. I'm just zooming to show you better. See, there is option normalize features, and in normalize feature 5 approaches are there, and most of us are working in min-max normalization, which is normalized to interval 0 to 1. You can also change. You can normalize -1 to 1. You can also go for G-score normalization. You can go for standardized to mu equal to 0 and sigma square equal to 1. So in this way you can change, but I am go with this option, with min-max normalization. What do you mean by min-max normalization? We represent our data within a certain range. आपको minimum value and maximum value आप देंगे. Accordingly, your whole data is falls within that range. Okay. आप यहाँ पे 0 to 1 दिया है. You can also select -1 to 1. You can also select -2 to 2. As per your requirement, you can set the range. Okay. But most of the time we should set the interval 0 to 1. Next, then you again connect the pre-process widget with a data table. Now just pre-process to data. Okay, now I connect the data table with a line chart, data to time series. Okay, and अभी मैं आपको दिखाना चाहूँगा कि रेंज जो 0 to 1 एक्चुअली हुआ है या नहीं हुआ है. I just add the 3 data. This is x2, this is x3. आप जैसे यहीं पे and suppose we will change the approach, then what should be the result? We can also live analysis using Orange. देखिए यहाँ पे हमने सिलेक्ट किए हैं normalize to interval 0 to 1. You can see the line here. It is started with 0 and here this is 1. That means the whole line lies in between 0 to 1. In the similar fashion, x2 and x3 also lies between 0 to 1. Suppose I will represent to -1 to 1. Now you can see, we visualize the 3 plots. Now you can check the range is, see, this is -1, this is 1. That means it lies in between -1 to 1. Suppose you go for standardized mu equal to 0 and sigma square equal to 1. You can go with this. Okay, and here the range is -2 to 1.5. In this method, you can't predict the range, but min-max you can predict the range, because as per your requirement you set the range. Okay, so this is all about your data normalization, and here we can represent the data within a certain range, that may be 1 to 0 or 0 to 1, sorry, or -1 to 1 or 2 to 2 as per your requirement. Okay, suppose you ask me क्वेश्चन कि हम ये करने के बाद क्या हमारा आउटपुट जो रिजल्ट अच्छा आएगा? अगेन द आंसर इज इट डिपेंड ऑन योर डाटा. ऐसा नहीं कि जैसे लिटरेचर में हम पढ़ रहे हैं कि if we are not dealing with not normalize our data due to high variation among the data, and some data are near to mean or some data are very far to mean, so the model is not fit during learning process. But if we represent the data in min-max, sometimes the output is impressive, but some other times the output is not impressive. The training error may be increased. Okay, so at that moment don't go with min-max, you try another approach. Suppose 2-3 approach में आपको वही result आ रहा है, means the result is not impressive. Without normalization, output is good, but after normalization, output is not good. Then you should not normalize your data. Okay. So the answer is normalize is better, but it depends on the data. Okay. Another thing I have means as per my experience, आप जैसे भी कोई डाटा को नॉर्मलाइज कर देंगे तो लर्निंग प्रोसेस में जो टाइम कंज्यूम होता है दैट इज ड्रास्टिकली रिड्यूस्ड. सपोज आपको 50 सेकंड लग रहा है विदाउट नॉर्मलाइज, तो आफ्टर नॉर्मलाइज इट रिड्यूस टू 30 सेकंड और 35 सेकंड. ओके, डेफिनेटली योर टाइम विल डिक्रीज इफ यू नॉर्मलाइज योर डाटा, बट आउटपुट क्या होगा ये हम प्रेडिक्ट नहीं कर पाएंगे. ओके, तो यू टेक योर डाटा, you apply some pre-processing technique as we have discussed here, then you check. Okay, कि हमारा accuracy ज़्यादा आ रहा है या कम आ रहा है, ट्रेनिंग एरर ज़्यादा आ रहा है या कम आ रहा है. Okay, any doubt so far? Please feel free to ask. So this is all about your data cleaning. After that we will discuss about feature analysis, okay, and feature reduction. If you any doubt please ask. एक पार्ट खत्म हो गया है. Now we are in phase 2. In phase 2 we will discuss about feature engineering, that is feature analysis and feature reduction. तो ये feature analysis क्या है, जैसे हमने पढ़े हैं कि we are using some approaches to check which features are important to achieve the output. Or you can say that a feature how much contribute to achieve the output. Okay, सपोज हमारे पास 5 फीचर है, 5 से हम देखें कि 4 फीचर ही कंट्रीब्यूट कर रहे हैं, बाकी एक फीचर 0 कंट्रीब्यूशन है, तो उसको लेना ही नहीं है. सो इन आवर फर्दर एनालिसिस वी विल नॉट कंसीडर दैट फीचर्स. उसको लेके क्यों हेडेक बनाना है, कॉम्प्लेक्स टाइम कॉम्प्लेक्सिटी स्पेस कॉम्प्लेक्सिटी बढ़ाना है. तो बेटर इट इज बेटर टू स्किप दैट फीचर फॉर फर्दर एनालिसिस. जैसे भी मैंने आपको प्रेजेंटेशन में बताया था, लेस इज मोर. दिस इज द कॉन्सेप्ट ऑफ लेस इज मोर. हम थोड़ा कम लेंगे बट दैट इज मोर इफेक्टिव इफ वी कंसीडर द होल डाटा. सो दिस इज द कॉन्सेप्ट ऑफ कन्वेंशनल डाटा एनालिसिस व्हिच इज नोन एज लेस इज मोर. ओके, एंड इन केस ऑफ बिग डाटा हम बोलते हैं मोर इज मोर. जितना भी होगा उतना अच्छा है, जितना डाटा होगा उतना अच्छा है एनालिसिस के लिए. दैट इज सेपरेट थिंग. बट हियर we apply some feature analysis technique to check the feature the features how much they contribute to achieve the output. Okay, so let's start. ये कैसे करेंगे, just I am going to show you by demonstration. Okay, so take a real data set. एक simple data set लेंगे. Take a simple data set. Take a simple data set. तो देखिए ऑरेंज में आप जो पॉपुलर डाटा सेट है, यू कैन डाउनलोड द पॉपुलर डाटा सेट. कैसे करेंगे, यू सिंपली सिलेक्ट द डाटा विडजेट. मैं इसको और थोड़ा प्लस कर देता हूँ. here you double click the data set and you can see, I am just magnify. Now you can see different data sets are available for in different disciplines. Okay, देखिए Sentinels, HDI, smoking effect, cancer data set, adult data set, iris data set. So many data sets are listed from UCI ML repository. जो हमारा पॉपुलर रिपोजिटरी है UCI ML रिपोजिटरी, वहाँ से सम डाटा सेट को ये पिक कर रहा है. एंड आप सपोज आयरिस डाटा सेट को यूज करना चाह रहे हैं, सिंपली वो डबल क्लिक, दैट्स एनफ. ओके, डबल क्लिक कर दीजिए एंड क्लोज. अभी हमारा आयरिस डाटा सेट अभी रेडी हो गया है. कहाँ रेडी हो गया, यहाँ पे. हम कैसे उसको प्रीव्यू करें, यू सिंपली कनेक्ट विथ ए डाटा टेबल एंड डबल क्लिक हियर. नाउ यू कैन प्रीव्यू योर डाटा. ओके, this is beauty of this tool. If you have no data, then also you can perform data analysis. Okay, जो हमारा existing data set है उसको लेके हम data analysis perform कर सकते हैं सीखने के लिए, जस्ट फॉर लर्निंग पर्पज. सो हियर यू कैन सी what about the information about the data set. Now there are 150 instances are available. Okay, this is a real data set. So there are 150 instances are available and no missing data, कोई भी missing data नहीं है. And how many features are available? 4 features are available. Out of them there is a target class available and उसमें कितना value है? Value means classes. तो there are 3 classes. Okay, क्या क्या वो classes है ना? सेटोसा, वर्सिकलर एंड वर्जिनिका, 3 क्लासेस यहाँ पे दिया है एंड ये तीनों क्लासेस को ये शो कर रहा है. ओके, क्लोज. तो आवर ऑब्जेक्टिव इज टू परफॉर्म व्हाट? फीचर एनालिसिस. हम फीचर को एनालिसिस करना जा रहे हैं. सो लेट्स सी. देयर इज ए विडजेट रैंक. जूम आउट कर दे रहा हूँ. ओके, ये जो रैंक है इसमें आप जस्ट कनेक्ट कर दीजिए एंड यू सिलेक्ट डाटा टू डाटा, नॉट सिलेक्टेड डाटा टू डाटा. नाउ यहाँ पे आप क्या देख सकते हैं ना? रैंक ऑफ द फीचर्स और द प्रोबेबिलिटी ऑफ कंट्रीब्यूशन. यू कैन चेक. सी, आपको वो विजुअली शो कर रहा है. देखिए, दिस इज द पावर ऑफ दिस टूल. आई एम जस्ट जूम इन. अराउंड 1 2 3 4 5 7 अप्रोचेस आर देयर एंड इसमें आपको बता रहा है. देखिए, ये इंफॉर्मेशन गेन है, ये जीनी इंडेक्स है, एनोवा है, बहुत सारा अप्रोच है. उसमें आप देख सकते हैं कि ये जो 4 फीचर है उसमें से चारों फीचर से कितने फीचर है जो कि कंट्रीब्यूट कर रहे हैं एंड कितना परसेंट कर रहे हैं, वो भी जो रेड लाइन शो कर रहा है ना, वो आप देख सकते हैं. दैट इज द प्रोबेबिलिटी ऑफ अचीव द आउटपुट. ओके, और यू कैन से कंट्रीब्यूशन. तो यहाँ पे देखिए, सेपल विड जो है उसका प्रोबेबिलिटी मींस कंट्रीब्यूशन बहुत कम है. ओके, तो इसको आप ले भी सकते हैं, स्किप भी कर सकते हैं. इट डिपेंड ऑन यू. सपोज आप ये 3 को लेंगे तो 3 को ले सकते हैं. नहीं बोलेंगे नहीं ये तो ओनली 150 इंस्टेंस है, तो सर बेटर है कि वी विल कंसीडर द होल डाटा सेट. आप चारों को भी लेके एनालिसिस कर सकते हैं. ठीक है, बट सपोज यू हैव ए लार्ज डाटा सेट. सो एट दैट टाइम व्हाट टू डू? जैसे हम एक इमेज डाटा सेट का मैं आपको दिखाऊंगा. ओके, पहले इसको कॉपी कर देते हैं, उसके बाद उसको मैं दिखाऊंगा. तो इसमें देखिए, हाउ टू सिलेक्ट द मोस्ट कंट्रीब्यूटेड फीचर्स. तो उसके लिए आपको इधर मैनुअली सिलेक्ट करना पड़ेगा या देयर इज ए अप्रोच. सी हियर देयर इज ऑप्शन बेस्ट रैंक्ड 3. आप सिलेक्ट कर सकते हैं बेस्ट रैंक्ड 4. यहाँ पे मैक्सिमम 4 फीचर है, तो इसीलिए बेस्ट रैंक्ड 3 आप ले सकते हैं. इसको आप कम भी कर सकते हैं. जैसे मैं 2 करूँगा तो यहाँ पे ऑटोमेटिक 2 हो गया. यहाँ पे सपोज हम 1 इंक्रीज करेंगे तो नाउ इट इज शोइंग यू ये 3 सिलेक्ट हुआ है. ओके, एंड हुआ या नहीं हुआ है हमें कैसे पता चलेगा? यू सिंपली क्लोज हियर. ओके, एंड गो टू दिस ऑरेंज canvas. Now you connect the rank with a data table. आप अभी देख सकते हैं it should be reduced data. See here it is showing as reduced data to data. You have to select this क्योंकि हमने ऑलरेडी रिड्यूस कर चुके हैं. ठीक है, वी हैव सिलेक्टेड बेस्ट रैंक 3. तो यहाँ पे जो आपका आएगा 3 आएगा, आपका 3 फीचर यहाँ पे आएगा. क्यों? नाउ वी हैव सिलेक्टेड ओनली 3 फीचर्स फॉर आवर एनालिसिस. सो क्या क्या फीचर है? पेटल लेंथ, पेटल विड्थ एंड सेपल लेंथ. एक को हमने स्किप कर दिया है. ओके, तो आप पूछ सकते हैं कि स्किप करने से आउटपुट कैसा चेंज होता है, क्या होता है? आप इसको भी एनालिसिस कर सकते हैं. कैसे करेंगे? नाउ वी विल डिस्कस अबाउट हाउ टू मॉडलिंग, जो कि आपका डिफरेंट क्लासिफिकेशन टेक्निक है. सम क्लस्टरिंग टेक्निक्स आर आल्सो अवेलेबल. तो इसको हम कैसे मॉडलिंग करेंगे? तो अभी मैं जस्ट फास्ट मॉडलिंग कर देता हूँ, उसके बाद हम धीरे धीरे पढ़ेंगे. आई जस्ट टेक सी we will model using the reduced data as well as the original data. Then we just make a comparative analysis. Okay, so let's start. कहीं पे भी प्लीज डाउट है तो प्लीज आस्क मी. डाउट लेके घर मत जाइए, जो भी डाउट है मुझे पूछ लीजिए. ओके, सो यहाँ पे हम क्या करेंगे? we have to connect this data table with a test and score widget. And here you have to select data to data. Press OK. Okay. अभी आपको लग रहा है कि मैजिक देख रहे हैं, बट घर जब जाएंगे ना बहुत सारा डाउट होगा. ओके, सो प्लीज एट एनी पॉइंट ऑफ टाइम इफ यू हैव एनी डाउट फील फ्री टू आस्क. आप मुझे हिंदी में पूछ सकते हैं, इंग्लिश में पूछ सकते हैं, उड़िया में भी पूछ सकते हैं, बाकी मुझे आता नहीं है और कोई लैंग्वेज. ओके, तो प्लीज फील फ्री टू आस्क हियर. क्योंकि एज ए एम्प्लॉय इन ONGC हम डाउट नहीं रखते हैं. हमारा भी डाउट होता है, हम भी पूछ लेते हैं. आपका भी डाउट है, प्लीज आप मुझसे बड़े हैं तो छोटा भाई मान के पूछिए, या छोटे हैं तो बड़ा भाई मान के पूछिए. ओके, बट डोंट कैरी योर डाउट टू योर होम. उस टाइम पे आपको बहुत टाइम लगेगा टू एड्रेस योर डाउट्स. ओके, क्लियर योर डाउट्स. सो लेट्स डिस्कस हाउ मीन्स आफ्टर फीचर एनालिसिस व्हाट शुड बी आवर आउटपुट. सो क्या हम अप्रोच लेंगे? सपोज वी विल गो विथ ए रैंडम फॉरेस्ट. यू सिंपली टाइप हियर random forest, okay, and connect with the test and score. okay, यहाँ पे देखिए कुछ क्रॉस दिखा रहा है, वो हम देखेंगे क्यों क्रॉस आ रहा है. we will discuss. Random forest error due to some problem it is showing error. No problem, we will use support vector message. हम डिस्कस करेंगे why error is coming. okay, don't worry. And connect with this. Again we will check. See, SVM is okay. There is no problem in SVM, but some problem in random forest. We will discuss. Okay, you don't worry. तो अभी हम SVM लेके एनालिसिस करते हैं. अभी for the timing we should remove the random forest. Okay. See, you connect this test and score with a confusion matrix as well as a ROC. ये दोनों ग्राफ मैट्रिक्स यूज हो रहा है for performance analysis of your classification approach. Dude, this is a classification problem. How can you say that this is a classification problem? ना जैसे ही आपको डाटा को देखेंगे, यहाँ पे देखिए it is showing the target with 3 values. That means there are 3 classes. Okay, so due to you can separate your data into number of classes, 2 classes, 3 classes or 4 classes. That is your classification technique. But if it is a continuous, suppose 1.5, 1.3, 7.5, if the value is continuous, then we should go with a regression approach. okay, classification regression में यही difference है. okay, and regression में performance analysis के लिए अलग है. Confusion matrix will not work in regression analysis. okay, and ROC also not useful in case of regression analysis, but in case of classification these two are very helpful to analysis your model. okay, so let's check confusion matrix. इसका नाम ही confusion matrix है, but if you have any confusion please ask me. तो यहाँ पे आप देख सकते हैं कि हमारा जो ओरिजिनल डाटा सेट है इसमें 3 क्लासेस है, राइट? सेटोसा, वर्सिकलर एंड वर्जिनिका. ओके, तो जैसे ये डाटा सेट को मुझे पता है कि उसमें क्या है ना, तीनों जो क्लासेस है वो 50-50-50 है. 1 to 50, 51 to 100 एंड 101 to 150. तो एक क्लास 50 इंस्टेंस को बिलोंग करते हैं. तो अभी जो ये कॉन्फ्यूजन मैट्रिक्स देख रहे हैं उसमें देखिए हमारा रिक्वायर्ड फील्ड क्या है ना, ये तीनों हमारा रिक्वायर्ड फील्ड है. शायद मैं जूम करने से आपको अच्छे से शो होगा, जस्ट जूम कर दिया. सी, यहाँ पे देखिए ये जो डायगोनल ये है, जो मैट्रिक्स का जो डायगोनल ये एक्स जो ये है उसमें क्या है ना, दिस इज आवर रिक्वायर्ड फील्ड. यहाँ 50-50 होता तो ये सबसे आइडियल केस होता, या 100% एक्यूरेसी, वी हैव अचीव्ड 100% एक्यूरेसी. बट इन केस ऑफ सेटोसा यू कैन सी देयर आर नो टाइप 1 और टाइप 2 एरर्स. ये क्या होता है? प्लीज गो टू थ्योरी एंड आप पढ़िए. थ्योरी का पार्ट हम डिस्कशन नहीं करेंगे क्योंकि टाइम ही नहीं है. एंड नेक्स्ट सेकंड देखिए, इसमें देयर आर 2 मिसक्लासिफिकेशंस, and in case of Virginica there are 3 misclassification. okay, तो इसको हम क्या कर सकते हैं, we compare with the original data. ठीक है, ये तो हमने reduced डाटा लिए हैं, तो ओरिजिनल डाटा लेके हम देखेंगे. ठीक है, तो बेटर आई विल जूम आउट and connect the original data. This is the original data with a test and score. okay, I select data to data and then I select another SVM model, same SVM model लेंगे हम, and we connect with the data table. Okay, and now we again connect the same test and score with a confusion matrix, and you rename it, otherwise confusion हो जाएगा, because its name is confusion. तो उसका नाम दे देते हैं ओरिजिनल डाटा, मीन्स कन्फ्यूजन मैट्रिक्स विथ ओरिजिनल डाटा, एंड यहाँ पे जो कन्फ्यूजन मैट्रिक्स है उसका नाम दे देते हैं रिड्यूस्ड डाटा. नाउ वी विल चेक द बोथ कन्फ्यूजन मैट्रिक्स, एंड आपका जो लर्निंग रेट है इससे ही पता चल जाएगा कि कौन सा अच्छा है, ओरिजिनल अच्छा है या रिड्यूस्ड अच्छा है. तो मैं ओरिजिनल का जो पार्ट है लेफ्ट साइड रखता हूँ, एंड जो रिड्यूस्ड पार्ट है वो राइट साइड रखता हूँ, एंड वी विल विजुअलाइज द बोथ अप्रोचेस. ठीक है, एंड मैं जूम कर देता हूँ तो आपको सही से दिखेगा. नाउ आई थिंक the screens are visible to you, both windows are visible to you, and here you can see in the original data the class setos are 100% classified, there is no misclassification. Okay, and what about the second class? यहाँ पे आप देखिए सेकंड क्लास में ओनली 45 classified but 5 are not classified. Okay, and in the third data 49 are classified but one instance is not classified. Okay, तो आप बोलेंगे यार ये तो क्लास 2 में तो रिजल्ट बहुत अच्छा आ रहा है, इसमें 48 आ रहा है एंड इसमें 45 आ रहा है, बट इन केस ऑफ सेकेंड क्लास के लिए दैट इज वर्सिकलर के लिए रिड्यूस्ड डाटा में अच्छा रिजल्ट आ रहा है, बिकॉज यहाँ पे 45 है, यहाँ पे 48 है. ओके, बट थर्ड में देखिए ओरिजिनल डाटा में 49 है बट रिड्यूस्ड डाटा में 47 है. तो आप जैसे हम उसको एक्यूरेसी निकालेंगे, तो एक्यूरेसी का फॉर्मूला क्या है ना, ये जितना भी करेक्टली क्लासिफाइड है सबको मिला देंगे डिवाइड बाय द टोटल नंबर ऑफ इंस्टेंसेस, और रफ वे में आप कैलकुलेट कर सकते हैं कितना मिसक्लासिफिकेशन हो रहा है. 5 + 1 दैट इज 6, that means 6 instances are not classified correctly in case of original data, but in case of reduced data 3 + 2 that is 5 instances are not correctly classified. तो कौन सा मॉडल अच्छा हुआ? प्लीज आप चार्ट में मैसेज डालिए कि वेदर आवर रिड्यूस्ड डाटा प्रोवाइड ए गुड रिजल्ट और आवर ओरिजिनल डाटा प्रोवाइड ए बेटर आउटपुट. सो द हम बता देते हैं क्योंकि टाइम नहीं है. किसी ने आई थिंक चार्ट किए, कुछ मैसेज किए हैं. ओके, अटेंडेंस फॉर्म, नो प्रॉब्लम. तो हियर आप देख सकते हैं कि ओरिजिनल डाटा में हमारा नंबर ऑफ मिसक्लासिफिकेशन इज 5 + 6. ठीक है, ये तो बाकी सब तो 0 है क्योंकि ये सब मिसक्लासिफिकेशन है. जो डायग्राम में आ रहा है दैट इज द क्लासिफाइड, मीन्स करेक्टली क्लासिफाइड. अब बाकी जो आ रहा है आप लोअर ये देखिए, ये हायर डायगोनल मैट्रिक्स में जो भी एलिमेंट आ रहा है दैट आर अनवांटेड, टाइप 1 एंड टाइप 2 एरर्स. तो ये आइडियल केस में ये सारे 0 होगा. ठीक है, बट देयर इज सम मिसक्लासिफिकेशन, एंड व्हाट एवर द नंबर ऑफ मिसक्लासिफिकेशन, 5 + 1 हियर 6 बट हियर 5. दैट मीन्स इवन इफ वी रिड्यूस द डाटा विथ वन फीचर, हमें इसमें अच्छा रिजल्ट आ रहा है. तो इससे हम ये कंक्लूजन में आ सकते हैं, मीन्स वी कैन कंक्लूड दैट आफ्टर रिड्यूस द डाटा वी अचीव ए गुड क्लासिफिकेशन एक्यूरेसी एज कंपेयर टू द ओरिजिनल डाटा. और क्या बेनिफिट हो सकता है? टाइम भी कम लगेगा, डायमेंशन, क्योंकि डायमेंशन कम है, वहाँ पे 4 है, यहाँ पे 3 है. ओके, यहाँ पे वी हैव कंसिडर ओनली 3 फीचर्स बट ओरिजिनल डाटा में 4 फीचर है. आप मुझे पूछ सकते हैं सर 3, 4, 4 में क्या डिफरेंस है, एक फीचर आप हटा के क्या फायदा है? व्हाट इज इट्स रियल बेनिफिट? मैं आपको अभी दिखाना जा रहा हूँ. आई विल टेक ए साइबर सिक्योरिटी डाटा सेट, एक डिजिटल फॉरेंसिक डाटा सेट है, उसके ऊपर हम आपको दिखाना चाह रहे हैं. ठीक है, सो लेट मी शो यू विद द ओरिजिनल डाटा. यहाँ पे आप देखिए, आई विल कनेक्ट विथ ए ओरिजिनल डाटा. डाटा सेट नेम इज I just I think fraud data में no, ये तो it is very less data. Okay, I forgot to bring that original data set. Okay, actually we can means we can check using our image classification data. Just after 10 or 15 minutes, I will show you. Okay. So this is all about your feature analysis. Okay. Any doubt? Please feel free to ask. Then we should discuss about some feature reduction techniques. So यहाँ पे क्या क्या feature reduction technique available है? ना दो technique available है. One is go to unsupervised approach. The first approach is TSNE. This is our first approach. And second is PCA, Principal Component Analysis. ये दो approach जो है, these two approaches are used for feature reduction. तो फीचर रिडक्शन में हमारा क्या होता है, सपोज आपका जो ओरिजिनल डायमेंशन है वो m है, सो वी कैन रिड्यूस द ओरिजिनल डायमेंशन फ्रॉम m टू एज पर आवर रिक्वायरमेंट. ओके, आप 2 कर सकते हैं, 3 कर सकते हैं, 4 कर सकते हैं, एज पर योर रिक्वायरमेंट यू कैन रिड्यूस द डायमेंशन. ओके, इसका बेनिफिट क्या है, हाउ इट बेनिफिट फॉर अस. सपोज समवन आस्क यू कि हाउ टू विजुअलाइज हाई डायमेंशनल डाटा. आपके पास एक बहुत बड़ा डाटा सेट है, उसको आप विजुअलाइज करना चाहते हैं यूजिंग ए स्कैटर प्लॉट. इज इट पॉसिबल? नो. आप मल्टीपल वेरिएबल को स्कैटर प्लॉट में शो नहीं कर सकते हैं. तो कैसे हम करेंगे? द सिंपलेस्ट वे इज यू सिंपली रिड्यूस द डायमेंशन फ्रॉम m to 2 एंड विजुअलाइज. देखिए, जस्ट फॉर डेमोन्स्ट्रेशन पर्पज आई विल यूज TSNE. ओके, connect the data table using TSNE. Okay, then I will connect the TSNE value into scatter plot. आपको मैं दिखाना चाहूंगा कि ये जो डाटा सेट है इसमें कितना फीचर है. 4 फीचर है. ओके, सेपल लेंथ, सेपल विड्थ, पेटल लेंथ एंड पेटल विड्थ. इवन योर डाटा सेट कंटेन m नंबर ऑफ फीचर्स, नो प्रॉब्लम. ओके, तो ये क्या करेगा, बाय डिफॉल्ट इट रिड्यूस टू 2. यहाँ पे आप कम ज़्यादा कर सकते हैं, बट बाय डिफॉल्ट यू सी इट इज कैटेगराइज द डाटा इनटू 2 पार्ट. सी यू कैन से 2 क्लस्टर्स. ओके, यहाँ पे just for understanding I'm showing you the clusters, but it is not cluster. Okay, as per the principal components it is categorized the data into 2 part, principal component 1 and principal component 2, as like PCA. So यहाँ पे क्योंकि यहाँ पे आप मैं जब जूम करूंगा ना, यहाँ पे आप यू कैन सी हियर PCA component equal to 2. You can also reduce. Suppose मुझे 3 करना है, I can do that. 3 start. तो यहाँ पे क्या होगा, मैं जस्ट जूम आउट करता हूँ, आप मैजिक नहीं दे पाएंगे जो जूम करने से. देखिए, नाउ आई विल रिड्यूस द प्रिंसिपल कंपोनेंट टू 2 एंड आई क्लिक ऑन स्टार्ट. सो ऑटोमेटिक देखिए 2 हो गया है. सपोज मुझे 3 करना है, क्लिक ऑन स्टार्ट, तो ये 3 पार्ट में डिवाइड कर देगा एज मच एज पॉसिबल. एंड 4 अभी कर सकते हैं क्योंकि 4 इज द मैक्सिमम नंबर, क्योंकि 4 फीचर है तो मैक्सिमम आप 4 कर सकते हैं एंड मिनिमम आप 2 कर सकते हैं. ठीक है, ओके, क्लोज. नाउ यू कैन सी द स्कैटर प्लॉट एंड यू कैन ऑल्सो लाइव एनालिसिस. ऐसा नहीं कि उसके बाद ही स्कैटर प्लॉट करेंगे, हम जैसे यहीं पे बढ़ा रहे हैं या घटा रहे हैं. जस्ट माई हिंदी इज नॉट सो मच प्योर. ओके, प्लीज मैनेज. तो here you can live analysis. See, suppose I will increase the number of principal component to 3, and the moment I click on start, you can see here there are 3 color codes and the data is divided into 3 parts. Okay, similarly, suppose I will reduce the dimension to 4, and the moment I click on start, the data into divided into 4 parts. Okay, so as per your problem, आप बोलेंगे भाई 4 कैसे हुआ, वो तो 3 ही आ रहा है. तो क्योंकि यहाँ पे क्या दिया है ना, द कलर कोड इज आयरिस. ओके, यू कैन सिलेक्ट एक्स सी, दैट इज color code for your iris. Okay, right. So due to we are categorize the data as per their class level. Color coding हम apply करते हैं as per their class level. As a result, they are showing like this. Okay. So in this way, you can visualize your high dimension data using a scatter plot. Okay. Similarly, you can go with the same approach with PCA. PCA में भी आप क्या करेंगे? You just connect with a scatter plot and you change data to data. You can check. See, this is the output of PCA. Principal component 1 and principal component 2. Okay. And आप इसको tuning भी कर सकते हैं as per your requirement. So what is our objective? Now, suppose we have a large data with a huge number of high dimension data. Then at that moment, आप जैसे ही आपका लैपटॉप में उसको सिमुलेट करने चाह रहे हैं, तो वो क्या कर रहा है? आपको मेमोरी वायलेशन एरर, क्योंकि जो डाटा ड्यू टू द साइज ऑफ द डाटा इज मोर, इट इज नॉट process your data with the limited number of your memory, primary memory. So to avoid that, either you increase your primary memory or जो कि कॉस्टली है 16 GB रैम होगा, आप और 16 GB रैम परचेज करके लैपटॉप में स्लॉट होगा नहीं होगा, दैट इज ए सेपरेट इशू. So by using our resources more optimally, what we should do, we should use the concept less is more, and we reduce the dimension from M to as per our requirement, 2, 3, 4 as per our requirement. Okay, so this is all about feature engineering. Feature engineering is two part. One is feature analysis, second is feature reduction. So now I think we have covered different data pre-processing techniques and feature engineering. And now what to do? Now our next step is modeling. जो भी classification है या clustering है, वो हम we should learn. Okay, how to apply clustering techniques. So I will create a new canvas, and here we will learning for different clustering and classification problems. If you have any doubt, please feel free to ask. No doubt. दैट मीन्स मैं आपको सही तरीके से समझा रहा हूँ, या मैं जो बता रहा हूँ आप लोग को समझ में नहीं आ रहा है. थैंक यू. सो लेट डिस्कस आवर नेक्स्ट मोस्ट इम्पोर्टेंट पार्ट, दैट इज क्लासिफिकेशन टेक्निक्स. सो हियर व्हाट टू डू, वी कनेक्ट विथ द सेम iris data set, and see here I have set the iris data into target, close. And after that I connect with a data table. As I said, आपको प्री प्रोसेस करना है, you can also go with pre processing, no problem. Okay, so I will directly connect with test and score to show you the workflow of your classification problem. तो यहाँ पे हम क्या करते हैं क्लासिफिकेशन प्रॉब्लम में ना, आपका एक डाटा को दो पार्ट में आप डिवाइड करते हैं. वन इज योर ट्रेनिंग सेट, सेकेंड इज योर टेस्टिंग सेट. ट्रेनिंग सेट एंड टेस्टिंग सेट का रेशियो क्या होता है? देयर इज नो पर्टिकुलर रूल. यू कैन चेंज द रेशियो एज पर योर रिक्वायरमेंट, बट कॉमनली पीपल आर यूजिंग 80-20 और 60-20-20, मीन्स 60% for training, 20% validation and remaining 20% testing. So ऐसा कोई हार्ड एंड फास्ट रूल नहीं है. एज पर योर रिक्वायरमेंट यू कैन सेट द रेशियो. ओके, सपोज आपको डिवाइड करना है, मैं आपको सिखाऊंगा कि डिवाइड विदाउट डिवाइड हम कैसे करेंगे, एंड डिवाइड करते हुए भी हाउ वी कैन डिवाइड द डाटा यूजिंग टेस्टिंग एंड ट्रेनिंग सेट. वो भी ट्रिकी है बहुत. ये ऑरेंज में आप सब कुछ कर सकते हैं, मीन्स एज पर योर रिक्वायरमेंट यू कैन इम्प्लीमेंट. सपोज नहीं भी है, यू कैन ऑल्सो इम्प्लीमेंट इन पाइथन एंड इंटीग्रेट विथ इट. देयर इज ए पाइथन विडगेट हियर. सी, you simply type Python. Okay, so ये जो Python स्क्रिप्ट है, यहाँ पे you can write C. यहाँ पे मैंने Python का स्क्रिप्ट लिखा. आपको if you want to see, you can see. Here you can directly write NumPy का जो कोड है हमने यहाँ पे लिखे हैं, and you can also process array using NumPy, and you can also use this output with a data table. and you give input to the Python, and you get the required output. Okay, so this is the beauty of Orange. You can execute your own code. आपका खुद का कोड भी आप एग्जीक्यूट कर सकते हैं, एंड इसके ऊपर थोड़ा पढ़ना है तो यू कैन ऑल्सो गूगल इन देयर साइट widgets, means add-ons, how to design widgets or how to implement own widgets using Orange. You can refer plenty of documentation, plenty of information from their sites. Okay, next. So ऐसे भी आप implement कर सकते हैं जो आपके पास नहीं है, ठीक है, वो बात का बात है. In our discussion, we restrict our discussion without coding, how we can design our machine learning prototypes. ये this is our objective. Okay, so हम कोड में नहीं जाएंगे, बिना कोडिंग कैसे ये होता है पहले स्टडी करेंगे. So see here we used a model, suppose neural network. Okay, we will use another model, suppose random forest. We will use another model, suppose SVM. You can also use KNN. So as per your requirement, you can select a model, okay, and use that model to address your problem. Okay, then जैसे मैं न्यूरल नेटवर्क लेके करना चाह रहा हूँ. So how to implement? You simply connect the neural network with test and score. Okay, तो ये करने से क्या हो रहा है ना, ये क्या कर रहा है, आपका जो इनपुट डाटा है उसको लेके मॉडलिंग कर रहा है. ओके, एंड ये आपको आउटपुट दे रहा है, एंड यहाँ पे आउटपुट कितना आ रहा है ना, क्लासिफिकेशन एक्यूरेसी देखिए लिखा है 22% आ रहा है. दैट मीन्स आउटपुट इज नॉट एक्सेप्टेबल. 22% आउटपुट आएगा तो कोई भी एक्सेप्ट नहीं उसको किया जा सकता है. ओके, लेट्स टेक अनदर मॉडल एंड चेक. यहाँ पे देखिए क्लासिफिकेशन एक्यूरेसी 96% आ रहा है. तो ड्रास्टिकली SVM अप्रोच इंक्रीज द क्लासिफिकेशन एक्यूरेसी एज कम्पेयर टू न्यूरल नेटवर्क. क्लासिफिकेशन एक्यूरेसी जो CA लिखा है ना, दैट इज द क्लासिफिकेशन एक्यूरेसी. CA स्टैंड्स फॉर क्लासिफिकेशन एक्यूरेसी. ओके, देन व्हाट अबाउट KNN? यहाँ पे देखिए KNN में कितना आ रहा है, 97 आ रहा है. इट इज मीन्स इट्स आउटपुट इज इम्प्रेसिव. ओके, एंड व्हाट अबाउट रैंडम फॉरेस्ट? वी विल चेक देयर इज सम एरर. क्या एरर है देखिए, रैंडम फॉरेस्ट फेल्ड विथ एरर 1 वार्निंग. तो इसको हम कैसे डील करेंगे देखिए, जैसे रैंडम फॉरेस्ट में आपको करना ही करना है, ठीक है, तो ये एरर आ रहा है. तो इसमें आप क्या करेंगे देखिए, वी विल डिस्कस इट सेपरेटली. देखिए, I will connect the same file with the same data set, iris tab, then connect with the data table, and then I will go with data pre-process. Okay, and then here I will select data to data. मीन्स आपको जैसे एरर कुछ आ रहा है तो क्यों आ रहा है देखिए आपको पता चल जाएगा. आई एम नॉट श्योर वेदर इट इज वर्किंग और नॉट. देन data table. See here you select pre-process data to data. Okay, then you connect here data to data. Okay, and then I will use a test and score. Connect here, and also I will connect here. Now it generate I think same error, random forest failed with error 1. तो क्या हो सकता है, then you go back to again your data. So here I think there is some problem. So how to overcome that? I'm select column, I think. Yeah, here we can analyze क्या हो सकता है, हम अभी स्टडी करेंगे. See, these are the inputs, this is the target. It's okay, कोई प्रॉब्लम नहीं है. बट क्यों आ रहा है एरर? Then I will go to here, the file widget, and check categorical. Okay, what to do? यहाँ पे जो iris setosa, iris versicolor and iris virginica आ रहा है, you change them 0 to 1, 0 1 या 1 2 3. देखिए मैं हम इसको कैसे कर, टाइम तो नहीं है बट हाउ टू डू दैट आप कर सकते हैं, कुछ भी कर सकते हैं। देखिए नाउ आई विल चेंज द डाटा। कैसे करना है, आई विल गो टू द डाटा, डाटा माइनिंग, आई थिंक folder is data mining data, then this is the iris.csv. Okay, and here see I have already I think in CSV I replaced the class label to 0 to 1. Okay, 0 1 and 2. So now I think this CSV file will work. I just check whether it is working or not, क्योंकि कुछ अप्रोच होता है जो कि आपका स्ट्रिंग वैल्यू जो आता है स्ट्रिंग क्लास में काम नहीं करता है। व्हाट टू डू, आई विल सिलेक्ट the data as my CSV file. Okay, close. Now 0 1 2 3. Okay, then select column, yes it is iris, it's okay. Then pre-process, and pre-process there is no missing value, not required, there is no in feature analysis, and I will normalize the value 0 to 1. Okay, see, okay, even I uh, delete all kind of pre-processing, still it is not working. Random part fail with warning error. What is the error? Some scores could not be computed. Value error, max features must be in 0 n features. Have at least 2 distinct values on the data. Okay, selected does not have. Why it is selected? It should be data to data. Okay, still it is showing some error. Random forest warning error, max features must be 0 and features. Okay, number of volt 10, it's good. No. Okay, it is not, still it is not working. So उस बेटर ये इसको हम बाद में डिस्कशन करेंगे क्योंकि अभी टाइम नहीं है, बहुत सारा चीज पढ़ना है। ठीक है, सी सो हियर we have used KNN SBM neural network, or if you want to use some ensemble approaches like AdaBoost, you can do that. Okay, or suppose some other approaches are you wish to use, you can also do. So many approaches are there. कहाँ से आपको ढूंढना है ना, मॉडल के अंदर देखिए ये सब है। ठीक है, linear regression, logistic regression, Naive based approach, your Naive based approach, gradient boosting. Okay, different CN2, so different models are even normal tree is also available, decision tree you can also connect. Okay, and you can evaluate your result. You can see random forest is not working, but decision tree is working. See, suppose someone asks you what is the best model, means among 5 models which model perform better. So here you check the classification accuracy. सबसे खराब परफॉर्मेंस है न्यूरल नेटवर्क का, दैट इज 22%, एंड सबसे बेस्ट परफॉर्मेंस है KNN, के नियरेस्ट नेबर, which achieves 97.3% of accuracy. So in this way you can evaluate your model. Okay, and suppose जैसे हमने अभी इवेल्युएट कर दिया है, इसमें सबसे बढ़िया आंसर कहाँ पे आ रहा है ना, KNN पे आ रहा है, तो आई विल कंसिडर KNN एज माई बेस्ट मॉडल, बाकी सबको मैं डिलीट कर देंगे, जरूरत नहीं। ठीक है, इन दिस डाटा सेट KNN आउट परफॉर्म्स एज कंपेयर टू द अदर अप्रोचेस। उसके बाद अननोन जो डाटा है उसको कैसे हम प्रेडिक्ट करें। ठीक है, ये तो हो गया नोन डाटा। सपोज हमारे पास कुछ अननोन डाटा है तो हम इसको कनेक्ट करेंगे। ओके, देन आई विल कनेक्ट विथ ए डाटा टेबल and then I will connect the unknown data to the test and score. Okay, and here you select data to test data. Okay, now if you want to check your output, you can check. See, the output is 97.3. आप बोल सकते हैं दोनों में सेम कैसा आ रहा है, इसीलिए सेम आ रहा है कि both data sets are same. You can divide the data into training set and testing set. Okay, तो कैसे उसको करते हैं देखिए, how to divide the data into training set and testing set. So for that, there is a data sampler. See, there is a data sampler is available, which is used to divide the data into two part as per your requirement. See, आप अभी इसमें select कीजिए iris data set. Now you connect this data set into data sampler. Okay, and you connect the data sampler with a data table. And यहाँ पे आप देख सकते हैं it is showing data sample to data. देखिए यहाँ पे there are two options in the data sampler, data sample and remaining data. तो हमने फर्स्ट टेबल में क्या सिलेक्ट किया है, डाटा सैंपल टू डाटा, एंड इन सेकंड टेबल आई विल select the second option. Automatically that second option will is select, but here it is not selected, so no problem, you manually select remaining data to data. तो आप इसमें देख सकते हैं, I just magnify, सेकेंड डाटा में क्या है, इट इज शोइंग 30 इंस्टेंसेस. तो ओरिजिनल डाटा सेट में हमारा कितना इंस्टेंस है, देयर आर 150 नंबर ऑफ इंस्टेंसेस आर देयर, बट in this divider, means in this data sampler, it divides the data into two part. One is the training sample, second the testing sample. And testing sample में ये 30 लिया है, and remaining 120 should be in training sample. Okay, so in this way you can divide your data into two part, and then you can proceed your model like this. हमने क्या किया, यहाँ पे एक टेस्ट एंड स्कोर लिया, सॉरी, एंड यहीं पे हमने डाटा टू डाटा सिलेक्ट किया है. ओके, एंड एक मॉडलिंग किया, जैसे कि आपको पता है कि KNN अच्छा रिजल्ट दे रहा है, तो बेटर वी विल कनेक्ट विद KNN. ओके, क्या 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 आया आंसर, एंड यू सिलेक्ट क्रॉस वैलिडेशन. ओके, सी देन फॉर अननोन डाटा we should connect with the test and score. Here we will select data to test data. Okay, and now we can check our output. Okay, so in this way you can, the main objective is how to divide your data into two part. One is training part and second testing part. तो इसको सपोज आप बोले नहीं संतोष, हमने ना 60-40 करना चाह रहे हैं, जो डिवाइड जो अप्रोच है हम 60-40 करना चाह रहे हैं. यू कैन डू दैट. यू सिंपली डबल क्लिक ऑन द डाटा सैंपलर. यहाँ पे आपको दिखा रहा है कि फिक्स प्रोपोर्शन ऑफ डाटा, यहाँ पे दिया 80%. आप इसको कम कर सकते हैं, 60% भी कर सकते हैं, 50% भी कर सकते हैं. ओके, एज पर योर रिक्वायरमेंट. सपोज हमने 50% कर दिया, या हमने 52, 53, 50, 60%. ओके, नाउ चेक. तो यहाँ पे नीचे आ रहा है out of 150, 120 are training and 30 are testing. But now when I set into 60%, now it is showing 90 instance for training sample and 60 instance for testing sample. So in this way you can divide your data into two part. This is your for training data, and this is for testing data. Okay, so in this way you can divide your data into two parts, and after that you go for modeling. Okay, so the discard, I just zoom out, and I think remaining 15 minutes there, so better we will discuss the image classification. Okay, it is very important, and जो कि इमेज प्रोसेसिंग के ऊपर काम कर रहे हैं, it will benefit for them. How to perform image classification using Orange. Okay, so let's start. I simply close, discard, close, discard. See, Control A, delete. Now we will discuss about image classification. So आपको सेट ऑफ इमेज दिया होगा एंड यू हैव टू क्लासिफाई द इमेजेस इनटू एज पर देयर क्लास लेवल. सो हमारा पास जो डाटा सेट है उसमें अराउंड 10 क्लासेस था. आई हैव रिड्यूस्ड 10 क्लास टू 2 क्लास, क्योंकि 10 क्लास लेके करेंगे तो बहुत टाइम लगेगा. So here you see it is very interesting. Without a single line of code, you can accomplish your task. So import images, there is a widget which is known as import images. So यहाँ पे हम क्या करेंगे, हमारा image को हम select कर सकते हैं. Browse, हमने क्या किया देखिए, I have created 2 folder. One is small train and small test. Actually the original data contains 10 number of classes, but I have reduced into 2 class. तो इन स्मॉल ट्रेन यू कैन सी, इसके अंदर आप जब जाएंगे देखेंगे डॉग एंड कैट, ओनली 2 एनिमल्स प्रेजेंट हियर, बट इन ओरिजिनल डाटा सेट अराउंड 10 एनिमल्स आर देयर, बट फॉर डेमोन्स्ट्रेशन पर्पज आई हैव रिड्यूस्ड द डाटा इनटू 2 क्लास. ओके गुड. सो मुझे ट्रेनिंग के लिए आई हैव सिलेक्ट दिस. ओके, सो इट इज शोइंग 421 images are there. See, 421 images are there with 2 categories. Okay, good. Then I will connect the image into image viewer. देखने के लिए देखना भी पड़ेगा ना क्या है. तो you can also see the images कि आपका क्या इमेज आप लेके काम करने जा रहे हैं. तो you can see image category and different options are there. So the images are classified into 2 part. One is cats and second is dogs. These are dogs and these are cats. हर एक इमेज में आप देखिए वो लेवलिंग हुआ है, कैट और डॉग. Right? Then हम क्या करेंगे, just for view the image we can use help of image viewer. Then we should use image embedding. जैसे मैंने आपको बताया था कि our prime objective is to convert the data into tabular data, means to convert any data into tabular data. That may be image data, that may be your textual data, that may be unstructured data. So you have to structure your data in a and represent your data using a tabular manner. जैसे रो एंड कॉलम मैनर में आपको यू रिप्रेजेंट योर डाटा. तो ये जो इमेज एम्बेडिंग है, इट विल एनकोड द इमेज इनटू टेबुलर फॉर्मेट. आई एम जस्ट कनेक्ट विद द डाटा टेबल, यू कैन सी दैट. तो ओरिजिनली हमारा जो इनपुट था सेट ऑफ इमेजेस, now by help of image embedding you can see we successfully converted the image into their different features. तो यहाँ पे अराउंड आप देखेंगे तो टोटल 2047 नंबर ऑफ फीचर्स आर एक्सट्रैक्टेड फ्रॉम द इमेज. इमेज से 2047 नंबर ऑफ इंस्टेंस आर एक्सट्रैक्टेड. तो देखिए कितना अभी इट्स ए हाई डायमेंशन डाटा. आप हमने एक इमेज को 2047 फीचर से हमने उसको रिप्रेजेंट किया है. ओके, so now we get the tabular data. So now we will start how to perform classification using the data. So before that, as I said earlier कि फीचर एनालिसिस में हमने क्या किए थे, 4 फीचर को एनालिसिस करके एक फीचर को स्किप कर दिया था. दैट इज नॉट ए बिग टास्क. चारों को भी हम लेके एनालिसिस कर सकते हैं. बट यहाँ पे देखिए जैसे भी 2047 जो फीचर है उससे सपोज हमने 50 या 60 या 500 फीचर कम कर सकते हैं. दैट इज ए बिग टास्क. ओके, तो नाउ वी विल अप्लाई फीचर एनालिसिस यूजिंग दिस हाई डायमेंशन डाटा. Okay, and you select data to data. It takes some time. Okay, and within 2 to 3 seconds, not 3 seconds, I think 20 to 30 seconds is required to perform the ranking, because it's a high dimensional data, so it takes more time. And it depends on machine, and this is a Xeon processor. This is a laptop with high resources, so it takes less time. But if you take a i3 i5 processor, then it takes more time. So now if you double click here, आप देख सकते हैं, देखिए जो रेड ये कंट्रीब्यूट कर रहे हैं. जस्ट स्क्रॉल डाउन. जैसे जैसे हम नीचे जाएंगे आप देख सकते हैं धीरे धीरे उसका कंट्रीब्यूशन रिड्यूस हो रहा है. सो ओरिजिनली वी हैव 2047 instances are there. So we will start reducing और कम करेंगे. देखिए दिस इज अ 2048 टोटल. ओके, तो हम क्या करेंगे, देखिए ये सब माइनरली मीन्स नॉट मेजरली कंट्रीब्यूट. सो आई जस्ट स्क्रॉल अप. हम यहाँ तक लेके 1000 लेके देखते हैं. ठीक है, बेस्ट रैंक्ड 1000. You can see not 100. Manually we have to select. Okay, manually we have to select. Okay, and you select up to 1000. Very interesting. और 10 मिनट पेशेंसली सुन लीजिए. I am just select the first 1000 instances. See, now we will check. Okay, I close it and I will connect with a data table. You can see here only 1000 instances are selected. Okay, only 1000. आप जूम करेंगे तो आप देख सकते हैं यहाँ पे you see total 421 instances with 1000 features, but the original data set contains 2000, more than 2000 number of 2047 number of instances, but we select only the first one, best ranked 1000 features for our analysis. Okay, and now we will perform classification technique on original data as well as reduced data. देखिए क्या आ रहा है accuracy. Data to data. Then I will use suppose neural network. Okay, and I will take another test and score and I will connect with the original data without reducing the feature. Okay, and same approach, neural network I will use. Then we will compare before reducing the dimension and after, before reducing the feature and after reducing the feature, what is our learning rate, or you can also represent it what is our error rate, training error rate. Okay, तो चेक कीजिए, दोनों को हम साइड बाय साइड दिखाएंगे. यहाँ पे मैं ये कर देता हूँ ओरिजिनल डाटा, वो मीन्स ओरिजिनल फीचर्स, and this is the reduced features. Okay, so double click and here also double click and you visualize them side by side. ओके, सो ये रिड्यूस्ड फीचर है, ये आपका ओरिजिनल फीचर है. देखिए क्लासिफिकेशन एक्यूरेसी में देयर इज नो डिफरेंस. यू कैन चेक द क्लासिफिकेशन एक्यूरेसी शोइंग 0.993, that is 99.3% accuracy, and the reduced feature also showing 99.3% of accuracy. That means we achieved the same accuracy but टेकिंग 50% ऑफ फीचर्स. हमने 1000 फीचर यहाँ पे लिया, यहाँ पे 2047 फीचर्स आर देयर. बाय टेकिंग 1000 फीचर्स वी सक्सेसफुली अचीव्ड द सेम आउटपुट. ओके, एंड ये आपका लैपटॉप में भी आराम से हो जाएगा. जैसे सपोज आपका 16 GB रैम है या 8 GB रैम है, दैट मीन्स इट इज ऑल्सो वर्किंग इन योर लैपटॉप. एंड सपोज आपके पास हाई रिसोर्सेस है तो आप वहाँ पे पूरा डाटा को लेके भी कर सकते हैं. तो अभी इसको फर्दर एनालिसिस करने के लिए कि क्या एरर आ रहा है, यू कैन ऑल्सो चेक. कैसे, देखिए कन्फ्यूजन मैट्रिक्स के साथ कनेक्ट कीजिए एज वेल एज ROC के साथ आप कनेक्ट कर सकते हैं. ठीक है, एंड कन्फ्यूजन मैट्रिक्स को भी आप टेबल के साथ कनेक्ट करके चेक कर. टेबल के साथ करके नहीं करेंगे, बेटर वी विल कनेक्ट विथ ए इमेज व्यूअर. इट इज वेरी इंटरेस्टिंग. सी आया है इमेज में, डबल की कर रहा हूँ. देन हम एनालाइज करेंगे, हमारा आउटपुट जो आ रहा है उसको एनालिसिस करेंगे. सी यहाँ पे व्हाट अबाउट द टोटल नंबर ऑफ इंस्टेंसेस 421, राइट. ओके, एंड हाउ मेनी कैट्स आर क्लासिफाइड एज कैट 218 एंड हमारा कितना कैट थे 219, तो 219 से 218 परफेक्टली क्लासीफाई हुआ है, एक नहीं हुआ है। कौन सा नहीं हुआ है चेक कीजिए। तो ये जो कैट है ये कैट नहीं हुआ है, ठीक है। इसको हम जूम कर सकते हैं, हाँ कर सकते हैं, देखिए हम इसको जूम कर सकते हैं। ये जो कैट है इसको हमने हमारा मॉडल क्लासीफाई नहीं कर पाया, ओके। इसको भी कर सकते हैं, उसको बोलते हैं मॉडल ट्यूनिंग। हम ट्यूनिंग करेंगे, हमें 2 ही घंटा है तो क्या सारी चीज कवर नहीं कर पाएंगे। सो बाय यूजिंग ट्यूनिंग अप्रोचेस और ऑप्टिमाइजेशन अप्रोचेस यू कैन ऑल्सो ट्यूनिंग योर मॉडल, ओके। यहाँ पे देखिए डॉग में क्या क्या प्रॉब्लम हुआ है ना, वेरी इंटरेस्टिंग। ये जो 2 कैट है दे आर क्लासिफाइड एज, 2 जो डॉग है दे आर क्लासिफाइड एज कैट, ओके। तो आप देख सकते हैं एज ए ह्यूमन बीइंग आई कैन इजीली डिस्टिंग्विश द इमेजेस एज कैट्स, बट डाटा सेट में मिस्टेकली दे आर लेवल्ड एज डॉग। आप देख सकते हैं यहाँ पे डॉग लिखा है, यहाँ पे डॉग लिखा है, बट एक्चुअली दे आर कैट्स। तो ये जो एरर आ रहा है इट्स नॉट एरर, ये आपका ड्यूरिंग प्रिपरेशन ऑफ द डाटा ड्यूरिंग द ह्यूमन एरर दिस कैट्स आर लेवल्ड एज ए डॉग, ओके, बट आवर मॉडल इज एक्चुअली वर्किंग फाइन। तो एक्यूरेसी आप देख सकते हैं आउट ऑफ 421 एक को छोड़ के बाकी सब करेक्टली क्लासिफाई वो किया है, दे आर एक्चुअली करेक्टली क्लासिफाइड, ओके, बट मिस्टेकली लेवल्ड, ड्यू टू दैट रीजन they are showing type 2 error, okay. Now any doubt please feel free to ask. Then आप मुझे बोल सकते हैं कि हाँ ट्रेनिंग एरर में तो 100% आएगा ना, मैंने आपको बताया था कि हाँ ट्रेनिंग एरर में आपका जो एरर रेट है लेस देन 1% आएगा तो दैट इज एक्सेप्टेबल। तो ये तो नियरली 100% आ रहा है, 99.99 आ रहा है, दैट इज ए गुड एक्यूरेसी, ओके। देन व्हाट अबाउट द टेस्टिंग टाइम? टेस्टिंग टाइम में हम चेक करेंगे कि हमारा एरर कितना आ रहा है, ओके। तो अभी इसको भूल जाइए, तो हमने प्रूव कर दिया है कि रिड्यूस करने के बाद हम अच्छा एक सेम एक्यूरेसी हम अचीव कर पा रहे हैं, इवन है वी हैव टेकन 50% ऑफ फीचर्स, ओके। देन अभी हम टेस्टिंग के ऊपर काम करेंगे। यहाँ पे हम टेस्टिंग सेट को लेंगे, ओके। जैसे यहाँ पे हमने ट्रेनिंग सेट को लिए थे, हियर वी हैव कंसीडर टेस्टिंग सेट एंड I will connect with the image embedding. Same approach, you have to apply same approach. Please don't forget, जैसे ही आप इसमें किए हैं ट्रेनिंग में, सेम अप्रोच यू हैव टू फॉलो इन योर टेस्ट डाटा सेट। यहाँ पे हमने रैंक लिया है तो सेम रैंक यहीं पे भी आपको लेना पड़ेगा, ठीक है। यू हैव टू सिलेक्ट रैंक, ओके, देन कनेक्ट द रैंक विथ ए डाटा टेबल। जैसे हम यहीं पे आपको कितना सेलेक्ट करना पड़ेगा, manually you have to select 1000, otherwise your approach is wrong. The methodologies used in training set, same methodology should be applied for your testing set. I am just going to
मिलन और विपरीत शब्द
विच्छेद
please ask any doubt,
छेद
just 2 minutes, give me 2 minutes, and after 2 minutes we will stop this session, okay. Please be patient. And here we will consider the same number of we will use 1000 best ranked features. I close here, and now I will connect it with the test and score. आप यहीं पे कनेक्ट करने के बाद आप देख सकते हैं रिजल्ट क्या आएगा, ठीक है। टेस्ट ऑन टेस्ट डाटा, यहाँ पे यू हैव टू सिलेक्ट द ऑप्शन टेस्ट ऑन टेस्ट डाटा, ओके। नाउ यू कैन, और ये एक अप्रोच है, और एक अप्रोच क्या है, आई एम जस्ट शो यू एनी प्रॉब्लम। यहाँ पे कितना हुआ है 1000 फीचर्स 100, ठीक है, no problem. After that you have to add another widget that is prediction, okay, and you connect with the neural network with prediction, okay, and then connect with confusion matrix as well as ROC. जैसे आपने थियोरेटिकल कॉन्सेप्ट में पढ़े होंगे कि ट्रेनिंग के लिए अलग है, टेस्टिंग के लिए अलग है। देखिए, दिस इज फॉर ट्रेनिंग and this is for testing. हमने सेपरेट कर दिया, ओके। एंड नाउ वी विल कनेक्ट द सेम कन्फ्यूजन मैट्रिक्स विथ एन इमेज व्यूअर, ओके। हम इसको डबल क्लिक करते हैं एंड यहाँ पे हम इमेज को चेक करेंगे कि हाउ मच एक्यूरेसी वी हैव अचीव्ड यूजिंग कन्फ्यूजन मैट्रिक्स। सो यू कैन सी, इमेज का साइज थोड़ा बड़ा कर देते हैं। हाँ, you can see the cat and dogs. There are 100 number of images are considered for analysis, and 46 cats are correctly classified and 4 cats are classified as dog. तो देखिए ये कौन सा 4 कैट है ना, एक्चुअली दिस इज ए लायन, बट ड्यूरिंग प्रिपरेशन ऑफ द डाटा इसको मिस्टेकली लिखा गया है, लेबल्ड एज कैट, एंड इट्स ए कैट गुड, एंड दिस इज ऑल्सो ए लायन। तो एंड ये कैट है बट इट इज ए लो रिजोल्यूशन डाटा, ड्यू टू दैट रीजन ये आपका मिसक्लासिफाइड हो रहा है, ओके। बट ये दोनों जो है कैट नहीं है, इट्स ए लायन, दे आर लायंस, ओके। तो ये दो को हम जब हम डाटा को करेक्ट करेंगे इसको हम करेक्ट कर सकते हैं, ओके। सो इन दिस वे वी कैन टेस्ट, एंड नो डॉग्स आर क्लासिफाइड एज कैट, 100%. All dogs are classified as dogs, okay, but only 4 cats are classified as dog. And what about that 4 cats? Now out of 4, 2 lions are mislabeled as cat, mistakenly labeled as cat, okay. That means our model is a good model, and it's a simple model, not a best model. But if you want to achieve more accuracy, then you can go for मॉडल ट्यूनिंग। बहुत सारा ट्यूनिंग पैरामीटर है न्यूरल नेटवर्क का। ये देखिए यहाँ पे रेलू, ये जो एक्टिवेशन फंक्शन, यू कैन चेंज द एक्टिवेशन फंक्शन, you can change the solver into Adam, SGD, so many, there are 3 solvers are available. But if you are using Python, there are around 9, I think 9 or 8 solvers are available, okay. You can also implement same thing using Python and integrate with Orange, okay. So in this way you can design your prototype using Orange, okay. So now I will conclude the session using the summary part, okay. So Orange is suitable for learning data science with small data sets. If the data set is very, very large, then Orange will not work. And if you are a Python lover, then you should use Orange. Otherwise, don't go for Orange. And if you Java programmer, then you should go for Weka, as I said earlier. And similarly, if you are a C, C++ and MATLAB programmer, then better use MATLAB. MATLAB also support visual programming. No need to write a single line of code using MATLAB also. And suppose आपको R पता है, तो you should use the package Rattle. So I think I cover almost all programming, 4 to 5 programming languages. How to design your prototype without writing a single line of code. This is our objective, okay. And these tools are available to mitigate your problem, and you can implement your problem without a single line of code, okay. Hope you enjoy this session. I would like to thanks to the organizing committee to invite me and give me to opportunity to interact among you. Thank you. And if you have any doubt, please feel free to ask.